3HOT.
Yes,
Yeah.
that's right.
He's gonna be speaking today. I looked there and I said, boy, he came all the way from Romania. So we really appreciate that. Thank you for
Thank
attending.
you for accepting
As
me.
well as
Thank you.
David G0MRF and Ram Schuvel. We also have Michael. It's oh yeah, he's from Switzerland. So it is quite a mixture, and it's always better to have more heads in the game because with more people thinking about it, we can do greater things. So thank you for attending. And at this time, I'm going to turn it over to our first speaker, David.
I apologize. We still are working on the microphones in the hotel, so you have to project a little.
Okay, no problem. Okay, there's a fair few people in the back row, just like some of the classes I've experienced in school. So I've got my eye on you guys.
We're the A row. We're the A's.
Absolutely. All right. Well, firstly, very nice to be here in Florida. A couple of weeks ago, I was looking at the TV news and I was beginning to wonder whether I'd be able to make the journey. Obviously, if you've come here today, you've seen the hotel hasn't remained entirely unscathed, but they've done really well to get everybody in the building today. Okay, what I'm going to talk about in this first presentation is a curiously named project, which is FunCube Lite on Jovian One. And as I said to the members of AMSAT UK a couple of weeks ago, if you've looked at this title and you think this is the first mission for AMSAT to Jupiter, then suddenly I'm afraid you're going to be rather disappointed. This is definitely Leo. All right, so AMSAT UK have been presented with an opportunity to fly a payload, a hosted payload on a university CubeSat. The CubeSat is part of a collaboration between 4 universities, University of Southampton, University of Portsmouth, and our old friends from a long time, University of Surrey in Guildford. They formed a collaboration known as Space South Central, which is to enhance the study of space engineering across the southern part of the UK. And they've formed this group along with 170 companies that produce products of software for the space industry in that particular geographic area. So if we go on, I guess I'm just pressing down on this, Drew. Page down.
Next.
Yeah, spacebar, I think, does it?
Okay, spacebar. Okay, so first of all, let's have a quick look at this curious title. The universities came up with a rather nice acronym of JUPITER, which is the Joint Universities Programme for In-Orbit Testing, Education and Research. So as we know, finding the acronym is frequently the most difficult part of any project. But having come up with the name Jupiter, they decided, perhaps wisely, maybe not, to call the first in hopefully a rolling program of satellite construction, a Jovian One. So we hope there'll be a Jovian 2, 3 and 4, but clearly a collaboration between 3 universities, pools resources, and with a bit of luck, the funding will be a little easier for a group of 3 rather than a university by itself. So the idea is to get people involved in space engineering, getting students with hands-on experience of satellite design and construction. I know here in the USA, you have this great collaboration between universities and the ELANA program to see things really get into space. In the UK, we're not so lucky. In fact, in the last 35 years or so, as far as I know, there have only been 2 satellites licensed to universities. That gives you an idea of the gulf between us. The earliest one was University of Surrey and their microsat project with Professor Sir Martin Sweeting leading it at that time in the mid-1980s. And about a year or so, maybe 2, there was a single CubeSat, 3U CubeSat launched by University of Manchester. Other than that, absolutely nothing. The regulatory environment in the UK is very, very difficult indeed. So we hope this is going to be the first of many. In fact, this is a very, very quick moving project, very fast moving. It's essentially a one-year project, and it was kicked off last March. And for the first few months of a one-year project, or thereabouts, it was essentially, what do we want to design? How can we do this? What's the budget going to be? Well, let's go and tap on all the universities' doors and try and raise several £100,000 to do it. AMSAT UK was sitting in the background, waiting for it to sort of kick off on a more practical level. And that didn't really happen until July. The actual project launch was on the 20th of September. So already we've gone from March to September on a project which is notionally about a year long. So this is the first photo that was released publicly. It shows a bunch of students from the 3 universities at Surrey Space Centre. And in the front there, we can see a model of what they hope to build, this Jovian One Satellite, which is 6U. And if we take a look at that, the most prominent feature of this is the slightly affected by gravity deployable solar panel, which when in space should be at 90 degrees to the body of the satellite. Also, taking a look at their 3D printed model here, you can see a couple of things. That's the Earth-facing side of it, we can see. And there's a sort of representation of a couple of patch antennas. This is going to use a commercial S-band and X-band for the downlink. So potentially some quite high-speed data, but not available in amateur radio bands. We, however, have installed another couple of antennas, and ours will be a little bit more accessible. So the Jovian One Satellite, if we take a look at the satellite first and then move on to the payload, it's a 6U satellite based on GOM space, structure and avionics. The students wanted something that could be built and launched within their time frame of being at university. And as we know, sometimes that doesn't happen. Students start on a project and then they never quite get to see it finished and launched. So GOM space was chosen because it was able to deliver the parts within a fairly reasonable period of time. And if we look at the types of things that they were going to produce, the structure, essentially the avionics, the communication package, ADCS, an onboard computer, they started delivering that 8 weeks after ordering, and they should finish delivering the rest of the parts within about 12 or 14 weeks, which in terms of some suppliers is really, really rapid. So that's a very nice thing to see. That deployable solar panel that we saw on the representation there on the first slide it gives the satellite a 45-watt power budget. It's actually 3 panels, the length of the 6U satellite, and when deployed, they come out at an angle. And if all the solar cells are optimally illuminated, the power budget is 45 watts. Obviously, in reality, we're not going to get 45 watts, but it's a considerable amount of power for what is a 6U CubeSat machine. So as well as the GOM space structure and avionics, we've got 5 payloads on board, 4 are university projects, some tech demo items, and 1 from AMSAT UK, which we're calling FunCube Lite. FunCube Lite because essentially it's very quick. We have to produce this very, very rapidly. And what we've done essentially is to dip our hands into the bag of toys we've managed to develop over the last 10 years or so, pick things out that we think will make a nice mission, and either use them directly or adapt them for this particular flight. The S-band comes in 2 varieties for the satellite. It has an S-band Omni. Omni's perhaps a little bit optimistic in terms of the actual radiation pattern, because if you imagine an omnidirectional antenna on S-band, it's relatively small compared to a large 6U structure. But if the satellite is tumbling and unable to get those patch antennas pointed at the ground, the omnidirectional system is capable of transmitting at a maximum speed of about 38 kilobits a second. So as a, if you like, an emergency backup, that's not a bad speed to get your data down. The command uplink will be in S-band. The downlinks are in S-band, either via the Omni or the patch antenna on the front. And the X-band is a downlink only system for higher speed data. The satellite includes a GPS receiver, which I think will be very interesting, trying to plot the data we're getting back against an actual position the satellite's occupying. And it uses CAN bus communication for most of the communication between the payloads and the onboard computer. I think it uses LVDS between payloads, but CAN bus is the main communication system we have to deal with. Very short project timeline for us. Payload delivery is somewhere between December 24 and February 25. So I think I know what my Christmas is going to be spent doing. So here's a CAD model produced by one of the students showing a few of the key features. Most notably that deployable solar panel on the top right-hand side. It is 3-section. It's got quite a few solar cells on there, but the key feature of that is if I point to the section there where it joins onto the structure, that's a rotatable joint. So the satellite is able to rotate that panel to try and optimize the illumination and maximize the amount of DC input to the power system. So that's quite ambitious. And clearly there's going to have to be a compromise between pointing that solar panel at the sun and getting the antennas pointing down towards the Earth if those directional patches are going to be used. So in this representation, in this CAD model, what we've got is the Earth-facing end at the far side of the satellite, which, we can't see that panel. And on the back side of the satellite here, we've got the, if you like, space-facing side. The solar panel itself, together with the rest of the system, as I say, can generate a maximum of 45 watts. If the solar panel remains undeployed, these things do happen, there are 38 solar cells facing the sun. If the panel is deployed, then that increases to 70, giving quite a substantial increase in potential power generation. Energy storage on board is going to be those lovely little lithium-ion cells we love, not lithium polymer. I've had some bad experiences with those, but the ones familiar in most CubeSats these days is that the 16850 or something cells. They're metal enclosed, and there are 8 of those in series. So by the time you add up the voltage from one cell, multiply it by 8, you come up to a nominal voltage of about 28 volts on the satellite bus. In practice, it will switch into sort of safe mode at 26 volts. So that's the low charge point. Fully charged, it comes to a tad above 33. So that's the sort of range of the voltage that's going to be used. Moving from power generation onto the AMSAT light payload, if you look at the bottom of this, we've had to add some antennas because obviously we couldn't use any antennas that were originally going to be fitted to the design. So we've used a commercial product, dipped into the funds, and we've got this on order. Sadly, it's not 8 weeks. And we have on here a UHF dipole, so UHF receive on this project. So one element of the dipole comes out on one side, one comes out over here. So that'll be the UHF uplink. And the downlink is something we always prefer because of the low path loss on VHF to the ground. We've got a monopole antenna for the 2-meter band. Now, if you think about the size of a 2-meter monopole, it's getting on for what, half a meter, 18 inches or so, 19 inches, something like that. That exceeds the height of the satellite. So really, for that to work reasonably efficiently, we need that solar panel to deploy because we're going to be working the monopole against the structure of the satellite. If the solar panel doesn't deploy, it'll still work, but the efficiency is going to be down. The SWR is not going to be optimized. So we're hoping that works out nicely. So let's just have a look at the Jovian One payloads. Well, the students are producing an imaging payload, including both stills and video, possibly with more than one camera on board as well, which will be very interesting. But the potential for getting all that data down and seeing some nice imagery is going to be, I think, quite good because of the S-band and X-band downlinks. They should be able to download reasonably large video files with that communication system. So all 3 universities are providing students on the imaging side of things. The other 3 university payloads are more experimental, particularly the second one listed there, an experimental proof of concept dark matter detector. Not even sure if dark matter exists, so it's going to be very interesting to see what results they get from that and how they interpret the data. Yeah, absolutely. Good luck with that. I've seen the design, and it uses a laser as part of the detector system. So internally to the satellite, there's going to be a laser beaming across a detection device with a sensor at the far end. All this is going to be very interesting to test on the ground, because how do you test a system that's designed to work in a sort of gravity-free environment or a free fall environment when you've got the flight model on the ground being affected by gravity? So it's a very interesting project. I look forward to reading the paper on it. Whether it discovers dark matter or not, who knows, but it's lovely to see a proof of concept with something so esoteric. Space radiation monitor. Well, this is a design, I think, from the University of Surrey Physics Lab. So it's a particular type of detector that they want to test in space. So that's, if you like, a PhD project, and they just want to get some space testing to prove this particular detector works. So that will be included as well. And then the 4th one there, I think we can really think of as an AI payload. It's an innovative tiny machine learning payload, is the official description from University of Portsmouth. And its purpose is to evaluate data from the payloads, analyze it, and try and look for trends and other repeating aspects of the data that's coming down, and try and make some sense of it on board and do some onboard processing of the data that's produced. So they will, all the university projects will be in a standard microsatellite format in terms of their fitting into the structure. So they'll all be based on satellite trays, which we're used to seeing for microsat projects. FunCube Lite, however, because it has to rely on things that we've either already produced or have been tested, is going to conform to the usual CubeSat format, where we use stacked boards and then mounted inside a space in the structure. So our main objective, as always, is educational outreach and, of course, amateur radio communication. So just a little bit more on the university side of things. The ground station antenna for this project is going to be located at University of Surrey. In fact, it's already in place. It's a 3-meter diameter dish. And for those of you who have ever tried tracking S-band with a dish, you'll know that finding something in space when it's 3 meters diameter is quite a challenge. It's 35 dBi gain on S-band with a beam width of 1.6 degrees. So if you can imagine the satellite being deployed, and then, you know, the KEPs aren't ever correct, are they, on those first few orbits? Trying to find an S-band signal with a 1.6 degree beam width antenna is going to be quite a challenge. From the UK, we think that the first pass is going to be quite low in the sky. So we hope that the AMSAT payload will be switched on at deployment, because we reckon we've got a much better chance of hearing signals on VHF with an Omni than they will have with the S-band with a very high gain dish. For those of you who like dishes, FD ratio is 0.45. Mission communications, commercial S-band is 2 gigs to 2.1, essentially. The downlink in S-band is 2.2 to 2.3, so separate uplink and downlink allocations for commercial spacecraft. And the downlink in X-band is in the 8 gigahertz region. It'll be allocated somewhere between 8 and 8.4. So it'll be nice to hear these things in space, but unless you're into deep space objects, I know there are a few people tracking things going around Mars and such like. Those frequencies are not normally available to amateur radio. Unless you've got a very nice SDR, of course, in which case you just type it up and there you go. So the tracking system on the dish there had to be improved. It was previously used for things like QO100, deep space objects. The rotator system on board the dish was not capable of tracking S-band or X-band in LEO. So I think the university spent something like £12,500 upgrading the rotators and the dish feed. And this one now has the resolution on tracking to be able to follow those microwave frequencies as they fly over fairly rapidly in LEO.
That's spin rotator.
I don't know offhand. I'm not sure. What I do know a little bit about is maybe not the rotator that's been chosen, but the dish feed. This is being manufactured in Holland to specification. It's essentially, on the left-hand side, here, 2 circular waveguides, one optimized for 2 gigahertz and the other one in the middle there for the 8 gigahertz or X-band. If you look closely on the left-hand side, you can see the 2 connectors here, and it can be configured for either right-hand or left-hand circular polarization on demand, so that's fairly handy. The 2 lower ones are the X-band feed, and the outer section here, which is the S-band, you can just see in the photo here, which is, I think, 3 weeks old. They've managed to drill the holes for the connectors, but not yet fitted them with the probes. So this is an ongoing project. Should be ready fairly shortly, and then it will be fitted to the dish and tested out on some already in space hardware. After you've got the dish feed, there are this little adapter plate on the image on the right, which has 4 legs on it. That will allow it to be fitted to the struts. That will testing. Does this work? Yeah. Okay, that's good. That will allow it to be fitted to the struts on the edge of the dish, and also allows it to be finely tuned to find the correct focal point for both of those feeds. I imagine they'll focus on the X-band, and then the S-band will just be okay in that position. So, having looked at the overall plan of the satellite from the universities, let's go on to the FunQ Lite payload, which is what we're trying to produce in an extremely short period of time. From what we have available to us, we have decided to put on our standard BPSK telemetry, which you'll be familiar with from AO73 and Naive One, etc., etc. So 1200 bits BPSK. We'll be aiming that essentially at educational outreach. And the universities, as always, like people to organize these things. So there is already a public engagement and outreach subcommittee. I'm trying to focus on soldering rather than subcommittees, but we'll get around to that. We aim to have a single channel FM voice transponder on board. And that will be mode UV, and we'll be using 67 Hertz CTCSS. So when it's not in use, the CTCSS will switch off the system. So we try to make sure that we consume a minimal amount of power from the satellite. And if we meet that criteria, we'll actually be switched on for much longer than if we consume a huge amount of power. So that's quite good. BPSK telemetry and the FM downlink will be on VHF, and both will use 145.895. At least that's what we have on the application at the moment. What it means is that we will not have the FM transponder on at the same time as the BPSK telemetry. And we think that's okay, because it's likely to be initially BPSK during the illuminated part of the orbit and the FM transponder on during eclipse. And we can do that eclipse detection and change mode automatically. So we have lots of power saving modes consistent with the available budget. All of the payloads from the universities are concepts or development boards at the moment, and nobody truly knows what power they're going to use. So to be compliant with the mission, we have to sort of anticipate things going wrong and make sure that we have lots of different selectable modes that we can command it into that consume varying amounts of power. So we're able to do that. Autonomous mode change at eclipse entry is perhaps the most important. If you build any sort of satellite, the thing that kills it is power drain in eclipse. There's no power coming in and there's lots of power going out. So a very good technique to avoid catastrophe is to make sure that it detects the entry into eclipse, and when it does that, it just switches to a lower power mode. So you can collect lots of power when it's in sunlight, maybe transmit a lot of power at that time as well, but when it pops into eclipse, just make sure you don't drain those batteries too much. Depth of discharge is key to long life. Of course, we'll have a manual mode change via a UHF uplink. So that will be compliant with all the necessary regulation to turn things on and off. And we can implement mode changes, uplink messages and things like that for outreach. We'll be using flight-proven design due to the short project timeline. So things that we've flown on other missions like UQ1, One Sat, which is JO97, and a mission that we provided a payload for called SAO, which was an ESA education program. Didn't last too long, but we're pretty convinced our payload was all right. So we'll be looking at that as well. As always, Windows-based ground station software to decode the telemetry and display the results graphically or in tabular form, and an online data warehouse so that if the students really want to pick up data from us and analyze it, that will be publicly available. So just a representation of a standard CubeSat format. In fact, this is AO73 on the right-hand side. But the purpose of putting this slide in is really to show you the format, where you have a number of stacked printed circuit boards, a multi-way header on the far side. I think it's 104-way that links them all together. And around the edges, supporting rods, M3 rods, I think, with spacers to actually give it enough rigidity to make sure it passes all the vibration testing and things like that. So very standard CubeSat design, and we're going to use that stacked board approach on this project. So we need 4 boards to do what we have to do on this mission. We don't need a power supply. That's great. That's being provided by the main satellite, so we can cross that off of our list. But of course, we are being provided with 28 volts, and we need to regulate that down for the use on these boards. We've got a UHF VHF communications board, which is essentially the UHF receiver, and some repeater logic on there to make sure it all works okay. And if it doesn't work okay, something to override all of the things that have failed and just turn on the FM. So that's a good plan. Uplink 435.090 at the present time. Then along with that VHF communications board, we've got a VHF power amplifier with an FM transmitter added to it. And we'll look at that in a bit more detail in a minute. If anyone was at Dallas last year, I had those PCBs that arrived a few days before the meeting. So we've now put those together and tested it thoroughly, and it all seems to work very nicely. The command, control, and telemetry board is one that we're going to be revising from previous missions. But something that's new to us is this CAN interface board. And when you say CAN interface, you think that's okay. Every car uses it these days. But we found that every manufacturer seems to like their own idea of how that should be implemented. So GomSpace, for example, have something called Space CAN protocol or something like that. We've shown that to the people at the university, and they've said, oh, no, we don't like that. We'll invent our own system. So I think that communications is probably going to take as long as the rest of the hardware to put together. But, you know, it's the way it is. At least CAN is reliable, which is what I'm told. So we have something that we've called Cannibal. So, you know, it takes a while to think of these acronyms, but yeah, that's the CAN interface board. It also includes a radiation detector because we had space to put one of those on. We'll look at that in a few minutes' time. And of course, the switch mode power supply on there to generate the 9 volts we need for our PA board from the 28 volts coming in from the satellite. The stack height of those 4 boards is going to be something between 0.5 and 0.6 U. So if you think of a 1 U CubeSat, we need about half that height to actually accommodate the necessary boards. So we can do the boards. We're confident we can produce those with the right performance in time for the mission. But we also need a UHF VHF set of antennas and a deployment system. And that is something that AMSAT UK simply can't do. So what we've done here is we've gone to a group of people that we've used many times in the past and have friends there. ISIS Space in the Netherlands produce a very nice antenna deployment system. We took a look at this, and that image in grey at the bottom left-hand side is from a CAD model that they have freely available online. I'd like to show you some of the pictures of the real thing, but obviously you can't release information about commercial products, so we've just taken what's publicly available and incorporated this. The mechanical design of this is very intense. If you look at it as an electronics engineer, I don't like mechanics anyway, but even mechanical engineers look at this and say, wow, that's complicated. It is their best-selling product, and it's extremely reliable. The other thing that's nice about this is it's only, I think, 5.9 or 6 millimeters high. The antennas deploy out of the sides of it, as you can see above, and which leaves a totally flat plate on the top where you can put another solar panel. So if you incorporated this into a 1, 2, or 3 U CubeSat, you would just put a solar panel straight on top of that antenna deployer. In our case, it's on the bottom of the spacecraft. We don't need the extra solar cells, so that will just be exposed to space with its metal cover plate open to the vacuum. For the eagle-eyed of you in the audience, you'll notice there are 4 antennas in this deployment system. On a 6U satellite, you can't use 4 because one of them will be deploying underneath the satellite itself. So what we've done is we've asked for a custom model to be produced. One of those elements will be left off, and we'll simply have the UHF dipole out of 2 of the ports and the VHF monopole out of the other. So we think that'll work, and it was much cheaper and simpler than something specifically designed for a 6U satellite. So that's the option we've gone for. So looking at the way this is all going to connect together, we've got a sort of connection diagram here. Top left-hand side, the antenna deployment system, UHF and VHF antennas on it, linked into a board which is labeled RF power amplifier, but in fact is a complete FM transmitter as well. Bottom left-hand side, UHF receiver, the repeater logic, and some other switching that needs to be done. Command control and telemetry, essentially a board that we've flown before. We're just relaying that out to get the pins in the right place for this mission. And then finally, on the right-hand side, this cannibal CAN interface board with the radiation detector and a switch mode power supply on it. Those 4 boards are linked into a harness connector. So I think it's a Harwing Gecko series. Looking at Graham's nodding. So all the payloads will have one of those connectors on. We need CAN in from the satellite, and we also have to have a loop through to give CAN out to other systems. We have 28 volts going in, but also 5 and 3.3. So we take that from the main satellite bus as well, or the power distribution unit on the satellite. We have to regulate down the 28 volts to get our 9 volts for one of the systems we have on board. And then hopefully all of these talk to each other with I2C. So we've got I2C communication between those boards. And as you can see, there's a number of power supply lines, audio lines, and all sorts of things that need to be connected. So interface control documentation is really important if you're not going to make a silly mistake. So a look at some of the things that we're going to put on. This is a command control and telemetry board that we've flown on many occasions. It's essentially a Silink CPLD, which we found to be very, very resistant to anything we found in space. The first version of this was on AO73. It's performed faultlessly for 11 years at 600 kilometers and is still up there. Batteries may be failing a bit, but this board is working very well. It uses FRAM on the latest version to store text messages, and possibly, if we can talk to the students, some thumbnail images from their imaging system. So we might be able to get those down if we can get them to format them into a reasonable format that allows a fairly lower data rate system to handle those images. We did it for One Sat. There were some lovely images coming down that were preloaded. This time we're hoping that we can get some real images from space. Will be nowhere near as high resolution as their S and X band image system, but nevertheless, it would be nice to see something like this coming down in the amateur bands. So Silink's CPLD, command decoding. It also formats the BPSK stream to be modulated by the transmitter. Freescale CPU for telemetry generation, picking all the data up from sensors within these 4 boards. It can provide automatic mode switching in Eclipse by taking solar panel data and just determining whether or not the satellite's in sunlight or not. It interfaces directly with the ANTS system, the antenna deployment system from ISIS space. So we've used that before. We know this can control that very nicely. And as I say, memory, and the first version, 11 years in space. We've flown this on several missions. I think in probably 25 years worth of flight heritage, we've had one microcontroller fail, and that was on One Sat. But other than that, it's been pretty good. How am I doing for time?
15 minutes.
Sorry?
15.
Okay, lovely. So this is the board I had at Dallas last year. It started off on AO73 and other missions as simply a 2-meter amplifier and a fairly low gain 2-meter amplifier at that, about 12 dB. Gain around half a watt or so output. What I did last year was relay this out and add some features. And I'm glad I did because it proved to be really nice for this particular mission. It's an RF power amplifying using a Mitsubishi FET. These have never failed. So I think this year it's up to 25 years in space with no failures at all, which is very nice. It's got a small amount of data collection, 4 channels, PA temperature, forward RF power, reverse RF power, so we can see that the antennas have deployed and are working okay, and the power amplified DC supply current. So it takes in those things via an ADC and gives the output as an I2C data stream, which is read by the main controller. Another addition on the right-hand side here, that little white block is a power combiner from mini circuits. The original circuit just had 1 input and 1 output. We decided it would be very useful to have more than 1 input to this device so we can switch from different sources around the satellite. Glad we did that. It's got 3 inputs on here. We've decided to use 1 for the BPSK, and then we can switch the other one to the FM transmitter. So both of those can be combined here, but only used 1 at a time. But it means you don't have to use power switching, RF switching. If you build in an RF switch into the satellite and it suddenly fails, you've had it. With this system, it's entirely transformer based, and so it offers greater reliability than an active switch of some sort. We've also added a preamp to this, so a driver transistor. So the whole thing now has about 29 dB gain. So for half a watt out, you need less than a milliwatt going into it. So it's really quite a useful system. We'll have a look on the back of that in a moment. We've also added a Skyworks or Silicon Labs, I think it was at the time, a VCXO for the FM transponder section. FM receive requires a fair few components. FM transmit is really, really simple if you make 1 or 2 sacrifices in performance. So if we have a look at the back of this board, over here is the FM transmitter that's going to be on Jovian 1. It is simply 1 single component here, an SI 550BE, and the other components around it are essentially a low-pass filter and a bias network to set the frequency that you want it to work on. So you can move it a few kilohertz either side of its nominal frequency and hone in on the frequency you've been allocated. So extremely simple, and hopefully will work well. So we've done a little bit of testing with this. That's the transfer characteristic of the amplifier on the top right-hand side. So less than a milliwatt in and a half a watt out on this. We've also pushed it up a bit to just over 600 milliwatts, and that graph just continues going up in a linear fashion. The quiescent current on the transistor is 25 milliamps at 9 volts, so it's not a huge amount of power. I think the device data sheet says you should run something like an amp quiescent current. So he took absolutely no notice of that and said, well, 25 milliamps is what we can afford. How does it perform? And the answer is really well. And so we need the linearity for the BPSK. The FM, of course, it doesn't matter. So we'll just push that a little bit harder. The bottom side of this, and here's the compromise. That spectrum analyzer plot is me trying to get the deviation to exactly 3 kilohertz. And whilst deviation meters tend to be a bit variable in calibration, there's a lovely technique for setting something like this, which uses a carrier null. So if you imagine a transmitter transmitting on a specific frequency, when you start to FM modulate it, and you look at that frequency, that spot frequency it's supposed to be on, as you apply modulation and you turn it up, at certain frequencies, that carrier will go down into a null. And if you have a look at that spectrum plot there, the middle peak there is much reduced on the peaks around it. And a little bit of math, as they say here in the USA, shows that at 1247 hertz, if you turn that deviation level up till the peak reduces in amplitude, when you get to that point, it's exactly 3 kilohertz deviation. So that's how we've set it. So that one's all working. Telemetry standard FunCube format, 1200 bits per second with forward error correction, 24 5-second frames over a 2-minute period. So if you get 2 minutes of telemetry collection, you've got all the data. Real time, whole orbit data over, I think at the moment it's 104 minutes worth we collect during the orbit. And we'll have 4 200-character text messages, which we can use for schools outreach. I've done a little bit of this with classes in the past, and you see the kids listening to this beeping from space, and then suddenly their names come up on the monitor they're looking at, and you can see the smiles go from one side of the group to the other as they see their name coming down from lower orbit. We'll be collecting 12 channels of data from the FunCube Lite payload. So we've got a couple of chips in there. It's the Maxim series. So a 607 is 4 channels, and 609 is an 8-channel device. So very, very simple to use. The radiation sensor is a BG51, which I think is from Switzerland. So thank you, Switzerland. And we'll be looking at counts per minute. So it'll actually be measuring rather like a Geiger counter. You'll get a count over a 1-minute period, which will count up and then download that in the telemetry as well. From the CANAS system, we're still wading through the mountains of manuals that GomSpace have provided, but we'll be picking off all the interesting telemetry there, including the GPS positional data. And we hope that the radiation sensor with the GPS data should generate some very interesting spot radiation readings around the planet. Things like the polar regions, the South Atlantic anomaly, they should be visible with this system when it's plotted.
5 minutes.
Thank you, Graham. So we'll rush through this last little bit then. RF communication board. This is, in fact, I was designing parts of this on the plane flying over here, so missed the movies, scribbling this out on the way, which is quite good. UHF input, SAW filter and LNA, FM receiver on 435.090, giving you command out on the right-hand side as an audio stream, but also audio going into the CTCSS system, so that when we enable the FM, we can use the same audio output for the communications downlink. Of course, we've got some control logic in addition to the 67 hertz detector, so that if there's multiple stations trying to uplink to the satellite, 67 hertz triggers a timer. We've got it set for about 10 seconds in the design at the moment. So hopefully if somebody doesn't have that, you can, I've heard QSOs over here, they're very impressive, very short too. One station with CTCSS can access the satellite. You can exchange the information, drop the carrier, and it will still remain active for somebody else for another 10 seconds. So that should enable people to use it who don't have CTCSS on their radios. We've also got a command that completely overrides the CTCSS system, because at the AMSAT UK meeting a couple of weeks ago, somebody said, do you know we can send digital digital communications through an FM system, but the CTCSS requirement wrecks it. So we said, okay, no problem. So we've arranged to bypass that as well, in case anyone wants to try something a little bit exotic. Down at the bottom, 3 separate blocks, also on this board, baseband telemetry coming in from the CPLD. There's a bit of a low pass filter on that to get rid of any edges, BPSK modulator, and another one of these marvelous little single chip devices from Silicon Labs to generate the signal. So nothing complicated, nothing to lose lock and go drifting off into another part of the spectrum, pre-programmed before it goes up, and it can't go anywhere else. The only thing you can do is fail, but we reckon they're pretty reliable. For the communications board, we are essentially combining bits of 2 boards that we've already flown. At the top side of this, I think we can call this a heritage design, perhaps a little bit like the old Fox satellites, except we have a bucket load of spare parts, so we can still do that. At the top, we've got a dual L-band receiver. So what we're producing now is slightly easier than that, because we're down on UHF as opposed to 1264, I think is we were using there. And the bottom part of the 2 images there is a dual transmitter that we used on ISAO, and we only need about 1/3 of that board. So we're combining those 2 and producing 1 board for the mission, but tested in other applications, so we're fairly convinced it's going to work. Finally, we've got this Cannibal board, 28 volts in, 9-volt switch mode power supply to give us 9 volts output to the PA board, a resistive divider so we can have some measure of what's going on the power supply, so we'll have that in the telemetry as well. I've said a PIC processor there as a CAN interface. Apparently that's now, in the past few days gone up to an STM32. So we're looking at the power supply requirements for that, but that will give slightly better performance. And finally, this BG51 radiation sensor, which is good for, I've certainly tested it for beta and gamma radiation, but we think it should detect any charged particles that have enough energy to get through the casing. So that will be quite interesting, lower orbit as well. Power supply requirements for that, I don't know why people aren't flying these all the time, 25 microamps at 5 volts. You could put it on anything and not notice it. And there's a picture on the right-hand side to give you an idea of the size. Little 3-terminal device. So as we come to the end then, lots of things not mentioned. Jovian One, it's a fast-moving project, but hey, David, when's the launch date? Who are you going to fly with? Who's the launch provider? Where is the launch site? Are you going to be able to drive there from London? That's such a good one. Altitude of the satellite for communications, inclination of the orbit. Will you be able to get it in Norway? Lifetime of the satellite. Well, it's interesting. The concept of operations, which, hey. Okay, there we go. To be fair, not a lot of this is known, and things are being released on a very regular basis. So I think some of these questions will be answered within the next, month or 2.
Like a little emoji.
I know, it's very sad, isn't it? NDAs. Can't live with them, can't go to space without them. Okay, that's it. Thank you very much.
Time maybe for a question or two.
Frank, yes.
Yeah, there's the GPS receiver. How do you use this to operate space?
I guess, as I haven't seen it on the list of things from the university, that's going to be a commercial product. I don't know. They have flown GPS before. It may be something available in stock, or it may be a.
Gotta be very careful. Just give no warning.
Oh, I'm aware of the altitude and speed limits. Yeah, all of that's.
There's algorithms.
Yeah, indeed, but it's nice to see the little tiny patch antenna on top there. So somebody's thought about it. Hopefully they've thought about those questions as well. Yes.
So you had talk a little more about the 3-axis stabilized, how that's going to happen.
Okay, the 3-axis stabilization is 2 systems. There are magnetorquers, which will do the course movement, and there's a series of reaction wheels in there as well. So we should be able to do slewing of the camera across a particular target. So hopefully the accuracy of the pointing should be quite good. Certainly it's the camera that's that needs the direction capability rather than the patch antennas, which are probably 60 or 90 degrees beam range. Yes.
How much F-band we have?
Oh, do you know, I'm an RF guy, not a computer guy. It's like,
You have
okay,
sufficient
yeah,
amount.
thank you, Mark. Sufficient, but sufficient for what? I don't know. It might be something like 128 kilobytes, something like that. It's not much. So we're not looking at 10 megapixel, camera images in full definition.
We use a camera.
Okay.
Can't get larger chips. Just wondered.
Yeah, if we go down that route, it'll have to be something totally pin compatible so that we can just pop it in there and see if it works. And if it doesn't, take it out again. That's good. Yes.
I wonder who are the likely candidates to provide the launch? How are we going to get it up?
I'm sure there are many and varied.
Sufficient.
Yeah.
Sufficient. Burns.
If you're using PC104
Yeah.
connectors, is that because of connecting to a commercial product, or did you choose them for some other reason?
All of the PC104 series were chosen to interface originally on AO73 all those years ago with an EPS system that they provided. And on a later mission, we needed to interface with an IMTQ, which is essentially a detumbling device. So having had the requirement to do that interfacing, we chose that for the rest of the boards.
Because of those previous devices are the ones that which wires you can use. Because it's a problem because nobody is very consistent with those things.
Yeah, absolutely. The only thing we found consistent between the manufacturers are the supply lines.
Yeah.
Other than that, it's all over the place.
Yeah.
Yeah, absolutely.
Okay, thanks.
All right. Okay. Thank you very much. Drew.
I appreciate you guys bearing with us on some technical issues as we go. Karsten, you stand up for a second. This is Karsten, KQ4SJM. He's our AV tech, and he told me if I didn't double his allowance, he wasn't going to do it today. So.
Triple allowance.
Well, I'm going to charge him for the ride home too. Next up, we have CardSat, a step forward for satellite yeah, there you go. And excuse me if I don't get your last name right. Adrian Totu? Okay. Y03HOT. Let me get the presentation swapped, and here you can take the mic. And I get your presentation up here.
I'd like to say thank you very much to AMSAT that you accepted my participation to this conference. I'm very excited to be here, coming from Romania. I am Ham, and I may say that I am very proud that I enjoy radio from early age. Excuse me my English, so if you not understand me, I may repeat, or maybe you may ask to be more clear. So I'm a mechanical engineer, and I enjoy radio, as I said. My call sign is Y03HOT. So somebody should tell me what button I should push. Space bar. Okay. So this is my Radio Shack. I am working in HF. All these things I have in a second location near Ploiești, 60 kilometers from Bucharest, and I'm working. I'm located in Bucharest, and I'm working with all these equipment by remote. I have an 25 tower meter antenna with optic beam for 5 bands, and also satellite antenna, as you see in the second picture on the bottom, with 2 antenna for 2 meter, 2 antenna for 70 centimeter, and 2 for 23 centimeters. With all the equipment, converters, amplifiers, everything needed to work on satellite. I'm using Radio Deluxe, as you see on the, so on this menu, I don't have previous, it's here. So here we have HF system with Canyon TS990, and here is the satellite system with Canyon 2000. Computers, amplifiers, so vertical antenna, so space bar. So another picture with Radio Shack. As I said, I am engineer, mechanical engineer, and also I am flying like F2 pilot license, PPL, pilot driver license, and for ultralight. Why I came here? I came here to present a new concept, a new possible product that maybe amateur community enjoying to make satellites will accept. What is CARSAT? I have here several products, and I would like to invite you break time or anytime you wish to look at that. So CARSAT, 1 unit look like this. It's very small. It's a challenge because everything in our life now becomes smaller and smaller. So why to do big things instead to make small things, which will be cheaper and will cost not so much to launch them. So this is 1 unit. On this frame, you will have everything like switches. If I will give somebody this frame and with all switches and outlets and so on already fixed, and you will have the layout here, and you have an electrical circuit in your mind, you can design this in 2 weeks and produce it very, very quickly, very quickly. It's one concept is one board design. Everything on one board. And if you don't have enough place here, you can use a bigger one, like this. This is for 3 units. And what it is possible is to make it expandable. So this is a text from NASA, state-of-art small spacecraft technology, because saying that miniaturization will be part, it is and will be part of our life. Like our mobile phone now are smaller and smaller. 20 years ago, it was like a brick. Now everything becomes smaller and smaller. So this is a graph showing the tendency of miniaturization, and you have here weight reduction, size reduction, and everything will be more complex. Functionality will be more. So this is what we are doing every day, because all the components become smaller and smaller. Frankly speaking, when I see resistors and capacitors, 0204 something like this, and I have to weld it. I don't like at all. So I don't like. But this is true. Young generation like to do this, and our machineries that we that are available now, pick and place machine and so on, can do this. So to use that machinery is not so expensive, so we have to use it. So 1 unit size, 2 unit size, and 3 unit size. It's 10 centimeter, 20 centimeter, and 30 centimeters. Of course, it can vary, and because this is an open project, open proposal, is just a challenge for all engineers to try to put everything in a smaller space. So you see here, we put everything, like remote control flight, antenna, killing switch here, yeah, killing switch, magnet, system to burn the wire, burning wire for the antenna deployment, switch to confirm that antenna is deployed. On these black lines, there are we design, but you don't have to follow this. This is a concept. It is open. We thought it is good to put magnets for attitude control, passive control, one axis, but on the big one, you can use torque rods for 3 axes. So you can put everything in 1 centimeter thickness of this CARSAT 3 unit. And I will show you one picture later that this is a project we are working on this. Another project, which is also here, this is already, let's say, done. It's this one. It has antenna deployable, so it's a default. It's a default. Sorry, that's so familiar to use the microphone this way. So this is the antenna, default antenna. We use this here. This is big. It's a not plastic. It's big because it should be insulated. The frame it's made from aluminum. Aerospace aluminum 7075. Should be anodized and hard anodized. Like this is hard anodized. Frame. We have sensor. Thank you, Switzerland. Thank you. So sensor is here. With a picture also with our sensor. So looks like this. Here it's LoRa for radio, microcontroller, and battery pack. Battery pack has a keeping system. The battery pack, the pack looks like this. And as a PCB, we have to fix everything with screw. And on the back side of the PCB here, it's let's say way to heat the battery. Yes. But these are proposals. You don't have to follow this. I don't want to say that this is the only solution. I came here just to propose to AMSAT and radio amateurs that likes to do such things to consider this concept for the future. And we are ready to support as much as we can. Everything what is mechanical. So these small holes here, so there are some shapes here. This line is not straight. In these small holes we can put magnets. Small magnets also for this one unit to control, to have a passive control for attitude, position. This is a picture with the real one. Balloon to balance the dipole antenna. Microcontroller, switch 245, killing switch. We have also here the deployment system, like we imagine, but it will be different also. Connector to connect the other PCB, the PCB we have to connect the solar cells and fill them. And the battery pack. same pictures. This is the place for television sensor. This is already fixed here. We already order other. They develop new sensors, and we are thinking now to make a new version with scintillating materials. It's like a plastic, like plexiglass. You have to cut and put in the places. And the scintillating material, when radiation comes through, and it's emitting light. And if you have a very sensitive camera, you can count those lights. So instead to use a small sensor, because there are many, it's a low possibility of radiation to hit the sensor. It is better to use a larger surface. So this is one of our next project. So this is proposal. We are thinking to do for the 3 unit with altitude control with storm pros. We may use here, so there are battery packs like this. This is a radio, and this should be the onboard computer. With such products will be available separately, then will help exactly like it's a very big industry now related to the CubeSat. There are so many companies doing different kind of products, so it's quite easy now to buy antennas from ICs, long space, computer, and so on. For CarSat, only few products are will be fitted today because of the high. Another solution is to use expandable panels, so we can link together several up to 8 frames like this. So we have a big plate, or to make a tube that can be other kind of application like telescope. I don't know. With CubeSat, more difficult to do such shape. This is the deployer. It is here. So it has also based on a spring. So it used cutters to cut the wire to open the door. And it is valid for 3 unit size or 3 1 unit size fixed units. Another possibility is to use CubeSat and the secondary mission CarSat. If you want to go to Moon, and if you need a repeater on the way to Moon, or if you need to launch a sensor on the surface of the Moon or around, I don't know, some application around Earth, for example, you can use CarSat as a secondary. These are only our ideas, but not. I'm sure there are many other possibilities. Because of thickness in the big rocket, we can fix the CarSat deploy system between big satellites. So you can fit in the rocket better. So we estimate that this may be less than €1,000. You can make launch the CarSat 1 unit. Now you need a lot of money to launch 1 unit of CubeSat. Another possibility is to use CarSat to test different new chips in space. So because of the price, low price, if you make the right testing system and sending data to Earth, you can test new chips against radiation live instead to use very complicated and expensive testing rooms for X-ray, gamma rays, and so on. So I'd like to invite AMSAT to develop together CARSAT. So we are able to, we have a certification of 9,100. So this is hobby, it's not a business for me. So business is different. But I'll be very glad if some new CARSAT will be developed together with AMSAT. And invitation is valid also for Switzerland and for UK, AMSAT organization, for anybody who enjoy this idea. So I have facilities for CNC machining. This is our location in Baytoy. We have 3-axis, 5-axis machining, press brake, CNC press brake, testing equipment, shapers, testing, vacuum testing chamber, clean room, laser cutting CNC machine, very high accurate 5-axis machines. So I also made, and all of these investments are for CARSAT. I'm not doing the parts for other companies. So this is an anodizing line we produce by ourselves, a hard anodizing line, because when I asked big companies to anodize, hard anodize such small parts, I was afraid they will damage because you have that it's not so easy to hard anodize. You can burn the material here. And before pandemic, in 2019, I decided to make this with my team. It has a robot, open automatically every tank doors, move parts from one side to another. Everything was done for CARSAT, for this idea. So also testing, as I said, clean room, cycle corrosion testing, thermal vacuum chamber from Spain, from AMSAT, vibration system. All of these are necessary for any kind of satellite, if it's CubeSat, CARSAT. And I don't know how, for example, other organizations handle this, but if it's if you pay or if this third company will ask you will do for nothing, last payment, we can support almost for nothing. So it will be our pleasure. So thank you very much for once again for accepting my participation here in my presentation. I'm very honored. And I will leave this product on this table. There are some catalogs. There are also some chocolates from Romania. Please enjoy. Please enjoy. And if you have questions, please.
Any questions? Okay. Thank you very much.
Thank you.
That's very interesting. Next up, we've got Graham Shervill, G3 Victor Zulu Victor, working QO100 from beyond the nominal footprint. Yeah.
No, sorry. Oh, people up over there again. Struggle.
Uh-oh.
Yeah, we can slide over. Got two microphones now.
I think just the.
Okay. Sounds like I've got reverb. Yeah, good. Good afternoon, everybody. My name is Graham Sherville, G3VZV. I know you don't like to think about QO100 because it's below your horizon, but this is a bit of fun, so don't take it too seriously. I know it would be great if it was a few degrees further to the west, but we can't move it. It's not in our hands. So, yeah. So that's everybody in the room will recognize a footprint when they see it. A couple of years ago, AMSAT UK launched a challenge for North America to see whether it's possible to work QO100 from, I say the North American continent. I think Newfoundland counts as that. It's an offlying island, I appreciate, but we discovered that it's minus 0.9 to St. John, just below the horizon. We wondered whether it would be possible to have operation from there. Lots of unknowns. Would a normal ground station be enough, or would it need a big dish? Could activity even include DATV, digital amateur television? Would it be better? We've got some experience across the North Sea, from the UK to Europe, to Holland and Belgium. Sometimes the ducting on 10 gigs is much better if you're right on the sea, right on the beach. So would it be best there, or higher up, or lower down? What time of year? And I suppose, are these footprint maps actually accurate? So that was 2 years ago, nothing happened, and then suddenly, a bit like London buses, not one turned up, but 3 teams turned up in May earlier this year, all completely uncoordinated. It was led, Gopan and David and myself, but we all spotted that a Canadian airline called WestJet was suddenly going to start direct flights from London Gatwick to St. John's, which is made it much easier, certainly for David and I, to consider going. And I think it was the same for Gopan, rather than having to fly via Toronto or Halifax and all the baggage getting lost and all those sort of terrible things. So it was a 5-hour flight on the 737. It's terribly easy to get now from Europe to North America. So there were 3 groups. Gopan went out with his partner, and then Stefan and John. Stefan lives, I'm not sure quite where, Toronto, in Canada. Winnipeg, thank you. And John is in Nova Scotia. They set up a team, and David and I, just the 2 of us, decided we'd do it as well. There's also in the background a beacon team. Apparently there was a Dutch group who decided it'd be great to have a beacon there. They sent it out, then COVID came, and then unfortunately the Graham V1DZ moved on from his existing location, and anyway, it never happened until the beacon stayed there until we all turned up. It was a busy couple of weeks in St. John's. Not sure about this slide deck. I don't think it's the right one. Would you just bear with me 1 second? I'm sorry. That would be a real pain. Going from bad to worse.
While Graham's fixing that, I just want to remind everybody there is water and unsweet tea in the back, on the back wall, so you don't have to go up and yeah, well, it was an option, one or the other.
It's hard to take the sweet out.
Yeah. That way you don't have to go up and give your firstborn child at the restaurant for a glass.
Yeah.
Okay, so Gopan set up in a location called Petty Harbour, which he rented a house or a bungalow there, and looked out across the sea. You can see the pictures. That's the view he had out towards the east. That was on a sunny day. There weren't many of those. And he, like David, decided they needed a 50 centimeter, a 3-foot dish to stand a good chance, but those, of course, wouldn't fit very well in an airline hold. So he cut his dish in half vertically, and you can see that he was mounting his offset dish upside down, because with an offset dish it's quite difficult to get them to point right at the horizon. That showed the weather much more reasonably. That's the path across to Kyoto 100, and he made the very first contacts. Actually, ironically, the first contact he made was FT8, but with David, we hadn't left yet, so that was quite good. He made a good number of contacts, over 150. I can't remember the exact stats, but the signals were very variable. That's the whole thing. You could have hours went by when there was no signal at all, and then suddenly a little sniff, and then nothing, and then a big signal, and then nothing. And it's very unreliable, you can say that, but the path does exist. Our Canadian friends turned up with a big dish. I mean, that was a 3-meter dish, I think. Oh, was it 1.8? It looked bigger on the back of John's van there. They had difficult operating situation because they couldn't stay there overnight. Parks Canada wouldn't allow that. So they had to pack it up and drive it away, and they went and stayed in the hostel somewhere. And then every day they came back, I think, for 3 days, and we're not sure quite where they were pointing, and the signals were coming and going. Was the dish in the right spot? And they got cold and wet and cold and wetter. They did smile when we turned up, but that was short-lived. So we arrived. We identified a spot near Signal Hill. Anybody been to Newfoundland, St. John's? Okay. Signal Hill's the famous place just outside St. John, where Marconi sat and received the first transatlantic signals from Poldhu in Cornwall. So it's a sort of significant location. And we were just across the inlet. In fact, the location of our cottage was just there. The deputy assistant lighthouse keeper's lodge, which is on that Airbnb or whatever. So that's a bigger picture. That was taken on a very clear day. Some low-lying clouds, but again, we don't know what affects the conditions which make it possible at some times and not possible at other times. We did a lot of testing beforehand. That's a picture of myself and David's dishes in the background on top of a famous place, north of London, called Dunstan Downs. If you're gliding, people you may know Dunstan Downs for gliding. But it's a good radio site to the north and northwest. You can see the takeoff there. Unfortunately, we were looking for a beacon to the south. I was very uncertain that we'd find it, but we did. So David was right. And it was really useful to be able to prove that our dishes would go down to 0 and beyond, and then we could lift them up a bit to get to the horizon. Lots of packaging. I'd concluded 2 things. One, to carry hand baggage with a basic station in the small 1'6" dish, tiny dish, a laptop, this laptop, a Pluto box, amplifier all built in. I'll show that to you in a minute. So that if the baggage got lost, we'd have a backup, a standalone station. But of course, we wanted to take more, so you can see some of the boxes and cases. And oh yes, the vital bit that I forgot to put in the bag, but I didn't forget to take with me, the gaffer tape. Gaffer tape. Duct tape. Sorry, yes, duct tape.
There you go.
Sticks the things that are moving that shouldn't be moving.
Yes, got it.
So that was our location by the lighthouse. taken on a sunny day. I can't remember that, but obviously it was. And that's David's dish. David didn't cut his dish completely in half. He cut it in sort of 2/3, 1/3 with a join across the middle there, or across the top, which worked very well. And the mounting, the cottage was selected because A, it got a very good sight out across the water, and B, it had got a sort of patio decking area, or what we call, where we could mount the aerials. So it was carefully selected, and it worked very well. The only problem was that the weather in Newfoundland is variable, and they have a lot of fog. You can tell the flags flying in the opposite direction from the previous photograph. And with fog, by a lighthouse comes a foghorn. And, lights are directional, it can swing around. It's fantastic. The foghorn is an omnidirectional antenna. It was very loud. And unfortunately, I got the bedroom facing it. David was round the back. He was lucky. But, it was very loud, and it ran automatically, and I didn't find a way of where the sensor was to go and stop it. But I might have improved. An antenna farm. David's antenna is there. My six, I didn't cut mine in half. It's only a sort of 2'6" dish, the red one, that fitted in that big box. And then the really small one there is the one that I hand carried in hand baggage. So they just sticking out the window. Again, carefully selected location. A picture of what we saw most of the time. No, I was thinking of the picture, the on the right. Sure. The beer wasn't. And then suddenly it all hell broke loose, and there were signals everywhere. And on FT8, David was working. I don't know. He worked 100 as well. Yeah, something very good. And one CW contact, I believe. It was the key. Yeah. So the signals sort of appeared out of nowhere. But a lot of the time, the signals were really, really weak, and you can see. I'm not sure what it was just there, but very, very weak indeed. So that was quite hard. And then look, I think this is a picture taken by John and Stefan. I think that's off their system. That's off their receiver. That was what they were receiving in Newfoundland. And then the activity level that we created. This is the web SDR at Goonhilly that I was monitoring to see whether our signals were getting through. And that was a pilot. That's beautiful. That's about 30 kilohertz wide of people calling. I mean, one of the great things about QL100 is you can work, say your course EQ and say listening 10 up, and the 10 up can spread to 20, 30, 40, and nobody objects. It's got so much bandwidth. And you can work duplex really. I never went to the sea. I just stopped talking and then carried on. It's really, really fun. That was our operating situation. We were not in the cold and the damp. We were in a nice centrally heated cottage. David's station was over here, as you can see. Mine was spread out along the table here. Again, didn't need two laptops, obviously, but it's very, very simple. Actually, that's one of the messages I'd like to get across, that microwaves are not scary. Look a bit worn out there. You can see my fine business log keeping piece of paper there. I won't try and describe all the equipment because you can't see very much. But that's the laptop, which is this laptop here, and that's Goonhilly with the signals coming down there, and that's our receiver. That was a rather nice box of 200 watt PA, which I'd taken over to try and produce DATV, but we ran out of time. But it produced some very nice, strong SSB signals. Now, if this works, it will be a miracle. This is recording the name John Young Satellite. Operating in Greece in the month.
Good to hear.
Thank you. Your ERP in 14 California. They are one of the
That was one, hang on. And here's another one. You can see the S-line signal there.
Yankee 1 station, Yankee 1 station, over.
Hear the beeping of Lila in the background. That's an overpower.
Sådana undersökt att det Leila auslöst.
Thank you.
Det kan ju med du en driver då men ting tillbaka i bort på det som är smitt.
Can't actually remember who made that recording, but he wasn't very happy. So yeah, I mentioned the beacon before. That's the QO100 transmitter beacon that was sent over by P1 CMO and the Dutch team, and the big dish that they were trying to use. We did manage to meet some locals. This was not a de-expedition. This was not how many hundreds of people can we work on QO100. This was, does it work? Can we have fun doing it? So yes, we did have fun doing it, so that was good. David took me to all manner of places in St. John. He seemed very proud of his parking expertise then. And now I said, microwaves are not scary. I am no great constructor or microwave geek or anything really, but I have had the great luxury of being able to go to weird places. I went to South Georgia a couple of years ago, and Tristan da Cunha, way down in the south. And I thought it would be great to operate down there, which I did, with some success, some failures. But this is the box, okay? This is the box, the magic box that does everything. You plug the laptop into the black cable, you plug an aerial into one socket, X-band aerial, the S-band aerial into one socket, and an LMB output into the other socket, and you apply 12 volts. And how about that for construction technique? No photographs, please.
So elegant.
Isn't it elegant? Thank you, madam.
Functional.
Functional, yes. And it's been vibrated and shaped on ribs and aircraft, and it still works. So Pluto, the SG Labs, PA there, which is a fine bit of kit. A few milliwatts in the SG Labs. So the Pluto produces next to no power. There's a mini circuits amplifier that produces 5 or 6 milliwatts, which goes into the PA, which produces 20 watts out, which is plenty. And this little box is a bias T to provide the LMB with power, and that's a commercial box that converts 12 to 24 or 28 volts. 20, something like that. 24 volts, yeah, and that's all that's in there. So, and it seems to work. Anyway, the very last day we were there for I think for 3 nights. We arrived late Wednesday night, Thursday, Friday there, and Saturday we had to get out of the place by I guess 11 o'clock. That was an error. We should have stayed an extra night, because about 5 o'clock on Saturday morning, I woke up. Now, don't ask me why. It's time shifted, obviously, but I woke up about 5 o'clock and thought, oh, the foghorn stopped. I suspect that maybe woken me up, no foghorn. So I padded out of my bedroom into the shack, switched it on, and the QO100 was full of activity. It was live, it was there and everything. Wow. So I went and locked David up and said, get out, get up, the van's open. So we then spent 2 or 3 hours, maybe 2 or 3 hours working everybody that we could, having lots of great fun. The signals were still going up and down. There is a cycle, a fading, I reckon it's every 30 seconds, and it's quite deep. It's 20 or 30 dB on occasions. And what's causing that, we have no idea. But anyway, and it would have been good enough to have TV working. Sadly, we didn't, so I failed on that one. I had another box, by the way, and shown it to you. It was just like the box I have shown to you, but it was just very slightly different, and that was the dedicated DATV one. So I had all the kit and the nice 200-watt PA to hang on the end of it. So I had all the kit. But anyway, so we had to pack up very quickly. We had to be out by 11, so by 9 o'clock we were packing it all away. But we actually had the whole day to kill because we weren't flying till the evening. So David thought it would be a really good idea to go up to Signal Hill and do the touristic bit. This is the car park in Signal Hill, and you can see the clouds there wafting back, and you can see the North Atlantic. And then we thought, well, Graham, you've got this portable kit in your carry-on bags. Why don't we get that out, have a go, and put it on the car roof and see whether we could see any signals? And we could slightly. And then again, I compliment David by saying, because he had the idea, why don't we just lift up all this kit and go and go and put it on the wall there, the stone wall by the edge of the car park. Just rest it there, see if you can have a QSO. And that's what we did. That's the dish. It looks very big there, but it's actually very small. That's the LMB. We have in Europe we use a thing called a potty, which is not what you think it is. It's I think it's patch of the year. Thank you. Yeah, patch of the year, because it's a dual band feed. The 10 gigs go straight through there into the LMB there, and there's an S-band patch around it. So yeah, patch of the year. Now, how did I forget that? A portable dish that are available. I don't think they're still available. It's got a sucky-wacky sort of support, which is why I've got an aluminium plate there, spread the load, and it will sit on that. That's the box that I showed you the detail of behind the laptop, which you can see here, and on a 99 watt hour lithium battery, which would run this for ages, it seems. So would it work? Well, looks like I'm doing something.
It always looks like that.
Thank you, 7-3, Oscar Mike 3, Whiskey Alpha November. Thank
Sorry
you.
about the cars, just leaving the car park through the background.
QR10. Bye-bye.
Show you the other one briefly.
Yeah. GW8 GO1 of the G3 portable. Thanks for the 5x9. Were 5x9. Signals are now dropping. There is slow QSB, but we proved. Thank you for proving that it does
That's
work.
the North Atlantic out there.
TIXG 3VZB portable VO1, VG3 VZB portable Signal Hill, over. Thank you. 7-3, the VO1 of the.
Okay, so enough of the background noise. But as you can see, we were having an awful lot of fun, which was the whole point, I suppose. Anyway, lessons learned and thoughts for the future. Gratuitously, the weather in Newfoundland in May can be cold and damp. We just not just then, okay. We didn't actually see any icebergs floating by, but we did have that as one of the risks when we did the risk register. You know, would a passing iceberg get in the way? So it's not ideal for all. How the fog and rain affected up the RF propagation, I think it's still unclear. I suspect, or we suspect, that it's the weather actually at the horizon, it's the critical bit. What's happening, I don't know, 80 miles out, 50 miles out. Mention the QSB, and I have this theory, it's only my theory, nobody else backed up, it's actually polarization reversal, and what we were seeing was left-hand circular becoming right-hand circular all the way around. Looking back, we could have just swapped one over on one of the dishes and proved that. Very good with hindsight, you know. Yeah, I've talked about the height there in the North Sea. We were higher up than the other two stations, and then of course Signal Hill was higher up still. I don't think we proved one way or another. and as I've mentioned, the 30-second fading. Is it an effect that the geostationary spacecraft is not actually geostationary, it's moving around in a three-dimensional figure of 8, so is the footprint actually changing, and therefore comes back to the original, the footprint map's not sufficiently accurate? Really don't know. What would be really good, and this is a plea, is to have a beacon up there that's running or can be switched on, and with a web SDR receiver running as well. A bit like, if you like, my portable kit got permanently installed somewhere. And then we can really examine what's happening in terms of the propagation to have that. It only needs to be low power and a small dish. And I've apologized for the lack of DATV. So anyway, now a challenge, the next challenge. This is a personal one. This does not have the support of AMSAT UK or British Amateur Television Club. But if you look at where we were operating from at -1, St. John, there's actually another country down here. Offshore Newfoundland is Saint Pierre and Miquelon. I'm not sure of the pronunciation. Anybody do Miquelon? Miquelon, okay. Which is a French département, get that roughly right, and F Foxtrot Papa is the prefix. That's at -3. Well, I don't know whether it would work or not, but it's there for somebody to try. The only problem is the weather's not much better. It's a bit further south, but not much. Perhaps somewhere warmer, like the 8 Papa 6 might be nicer. And that's at -4. Well, I don't know, but it's nice and warm. You could sit there for days on end with your drink under an umbrella and just watch the world go by in Barbados.
Warmer may have better trouble.
Warmer may have better trouble. Good point. Yeah, that was one of our original thoughts about Newfoundland at the time of year. When would the trouble be best? Or my last offer. My last offer is not North America, I apologize, but it's South America in Guyana, 8 Romeo, where there's a de-expedition there at the moment, but not a QR100 one. And that's only -2.6. So there's some opportunities for you. Thank you for putting up with me for 10 minutes or so. I have to say we had a lovely time and had lots of fun, and that's what amateur radio should be all about. Thank you very much indeed.
Thank you. Any questions? Questions? We're due for a break here. Originally it was 2:45 to 3. We're going to make it 2:50 to 3:05. So take care of some business and be back here in 15 minutes, please.
Thank you. Sorry about that.
Terribly interesting.
Yeah. Okay.
Thank you.
What I expressed.
That works. They get it in focus on the screen and then shut the autofocus off because every time they reached across in front of it. Hi.
I didn't register for today,
Okay.
so I need to pay you.
Okay. Let me ask Paul how we can handle that. And if I can't find him, we'll.
I saw I could do it.
Let's go find Paul.
I started in 2004. And like what did you say? Started to one of my customers. I decided to try later on. She goes to, down. So the moment they had it, because
This cameras are.
I use this. I plug in here.
Yeah.
Okay. More slack on this thing.
Okay. Yes, we did. I know all of these things not moving, but then she knows. So, but I got Florida. I use CANAS technology. Paul and I go back and forth.
So I have prevent. Academy has only.
So I have a.
It's coming out of there, right?
Yeah, it's coming out right here.
Which one of these microphones do you use? This one? And then I would put the microphone on there, right? He's the expert in the whole place. So where's the mic? I mean, where's the speaker on this thing?
Like you just.
That's
what I'm trying to understand.
Yeah.
Fire it up. No, no.
I started. I didn't because from that time
Oh, you have
I feel where the
Yeah, I understand. Yeah, I know. There's much about
and what you got to say because I has not.
So is your allowance sufficient?
Like that. Right, so the only thing that, you know, last, Linda.
Yes.
Let's see. Your mic's not plugged in, and you're on some
Copy of the crack and then all these water.
I may have to play with that. FT8 is 15 seconds. So just, yeah.
Yeah, they're using 4 satellites. I'll tell you what.
It's like the third one hour. What it costs. How much? You guys run that jewelry.
Oh, that's even if you're going beside me, you know, I take a look and I've got this here, and then the rest of us in the world are blues and kind of yellows. I know what they're doing. They're running the same job. Beside me.
Way too much.
Well, and that's not.
Just to make things like that.
You might know they're making 100 plus out there.
Yeah, well, WSJT is not a QRP mode. It's a signal. Yeah. Multimeter, 77 meters. What Texas, hold on, sticks on it. So there's a time and a place for everything on.
Yeah. It was just randomly pieced by individuals. That's like all of the modes and all of the bands. Currently, I'm stuck on 167 one of that.
Yeah.
It was interesting. I talked to a lot of the Georgia, Jackson, Georgia, the other day on 106.
You're gonna say, oh, yeah, so that's not a problem. It's a bit. You have these singers, they go out, no, I can't.
If I know.
It's very similar to that.
So. So no experience to know that. So that's good. Yes.
They gonna lock this room overnight?
Oh, no idea.
So,
The other room, we locked and then our room keys would let us in, actually.
set up.
Oh.
My slides.
Yeah.
That's not doing it.
Yeah. Did you look?
Test it on.
See if it looks secure.
So anyway, it's hard to tell. First so now,
That's difficult. So driving to Austin, Texas. And driving to but then she's driving out fast herself on Monday. No, I see. Leaving it alone, talking about when we left the cancer. And other things besides.
This is always operation. Systems engineering.
well, I understand. Well, I'm on the board. Yeah, my son. So everything is going fine. If you like, I know, like. It's advised. But if I will. Well, they closed. Coming from 30th to 30th. Yeah. Shorts, the anniversary shirt. Oh, yeah, yes, he goes. Yeah. You've got room.
Two-minute warning. It's 3:03.
That was the final answer. Thank you.
Fabulous. Fabrication. No, it's amazing. It's amazing. Oh, wow.
Yeah.
But I do not see
So you're gonna give a about that.
You were moving back. I was, can you see through his?
Well, yeah. Yeah, it comes up. I suggest that he-
Good. It's a good presentation.
One minute.
Let me win.
We're all here. Let's go. When?
Okay. Good afternoon, everybody. I think you all know who I am, KA3HDO. And my talk is just going to talk about the 40th anniversary, our 40 years of AMSAT and ARIS and SAREX working together, but also a little bit of overview of where we are in the past year. All the other stuff is going to be presented tomorrow, hardware and from Randy Berger, and then Graham's going to talk about the EMTV capabilities, and Chris is going to talk about some of the activities we're doing on making our systems remote commandable. The only thing I'll say about EMTV is this is a mini tuner that will be discussed a little bit tomorrow for EMTV that the BATC team have developed a kit. And we had some interns under Lou's, Terry Banky's guidance building these things this year. So like I said, I'm going to talk about AMSAT, ARIS, and SAREX actually over the past 40 years. And the first thing I wanted to give you was a 2024 update. And I want to remind everybody about our program, just so you're aware. I mean, we have three main pillars in the ARIS program. STEM education or STEAM education is one of the most important aspects of this. But to do the STEAM education on space station, you can't do that without the flight hardware systems and without the flight operations. So all of those are intertwined, and it's getting, I'm very excited because over time I'm watching the three main departments, if you will, starting to really gel together to make things work more from a teamwork perspective. And of course, we're doing this all primarily with put a plug in for our sponsors. I don't know if you realize it, but $4 million of in-kind support comes in from NASA and ISS National Labs. If you go and query how much it costs, if you were a private astronaut to use crew time, it's about $4 million a year that we're getting as in-kind support just for that, not including the launches and everything else we get. ARDC has provided, a hunk of funding for our educational program. It's been very beneficial. And then, of course, the main foundation, if you will, of this is ARL and AMSAT. We've got a new partner we're working with now. This came up, was presented at the 40th anniversary, Estes Rockets. We have a synergy with them, basically, from an education perspective, we're sharing lesson plans and things like that, and attending conferences together and things. So it's a good beginning with them. And from a numbers perspective, some of you've seen this before. We've done over 1,600 contacts at this point since we first turned on the radio in November of 2020 and 2000. Almost 24 years now, and you can see the kind of numbers we're doing each year, affecting 40 to 200,000 students a year. And actually, this is the numbers from last year. And basically, we've got about 45,000 students last year that were directly or indirectly involved. Almost 250,000 people involved in all of the contacts, the conferences, the activities we do. And we've done a lot of it. What I will say is this, and I thank all of the individuals that have helped us in the education world, starting with Mark Hammond, and then Mike McCardle and Alan Johnston. From an AMSAT perspective and ARIS working together, the activities that are happening educationally have gotten significantly better than, Mark, you remember what it was in the old days. and we were getting in trouble. NASA didn't like the fact that we were just one and done type of thing with students. And yeah, we're doing amateur radio, but it's more than just amateur radio and things like that. And what amateur radio is, the first two letters of our our name, not the middle or the end. So and let me just say that we're also been doing things in high places. I'll say this girl guiding contact we have in the UK. With had Her Royal Highness Sophie, the Duchess of Edinburgh, that was at the contact. I want to show you the video of that, and hopefully I can do this and run over there quickly. Is it running? Not yet? Okay, hold on.
This is not on.
Yeah, that's a dead mic.
Oh, okay. I gotta use this one. I'm glad it didn't work right off the bat here. Yeah. That's it. North time.
GB4 GGB, this is November Alpha 1 SS, over.
Speaking. This is Sophie, Duchess of Edinburgh in the United Kingdom. I'm here today with over 100 brownies, guides and rangers from Girl Guiding Surrey West for our contact with you on the International Space Station from Brooklands Museum in Surrey, the original home of British motorsport and aviation. As president of Girl Guiding, well, actually now patron of Girl Guiding Association in the UK, I want to thank you for the inspiration you show to our young girls to pursue a career in science, technology, engineering, and mathematics. Are you ready for your first question, Cindy? Over.
Yes, I'm ready. Your voice.
Thank you. I'm glad to hear you too. This is all really exciting. So, your first question: who or what inspired you to become an astronaut? And what advice would you have for any of these girls here today who might want to follow in your amazing footsteps?
Well, I think my biggest influence had to be my parents, who are just allowed me or, showed me the way to try anything and don't worry about failing, don't worry about having a little bit of trouble, but just try different things and be encouraged. I think those are my biggest advocates when I was a kid. and trying to do things that were a little bit different. So I would have to say my parents, and I would say to the girls there, that same advice, like try anything and see what you like. You know, don't be stuck in one thing or another. See what science, technology, engineering, math, art, if you find that you like, then pursue it. Okay? So, you want to look at our simple printing. So we have a called the Kipling, where we compare, like I was looking just earlier and saw the sea ice in the Atlantic Ocean. Right now we're looking at the coast of Spain, so coming close to you. So those are some of the things to do and take with our wonderful planet, as well as I write a journal. Over. Within 24 hours period, so how do we look like that? We use Greenwich Mean Time, because that's in the middle of our mission control centers in the United States, and Japan, and Japan, and Germany. So we try to keep a normal schedule for us, and a normal schedule for our folks that support us. Over.
Um, I was on the other side of the pond and I was nervous to be doing it. So I can't imagine what Kieran, Graham, and others that were there from RSGB and AMSAT UK felt, but they did a phenomenal job. Congratulations. Thank you. So you know, let me just say that was royalty, but I have a couple other clips I want to show you that talk about the actual in-depth educational activities that are happening in ham radio specific activities. So I think a number of you seen this before, our ARIS 2.0 vision, you know, basically inspiring and engaging and educating students and lifelong learners. Now, how many of you are lifelong learners? Everybody.
You can't be a ham in that.
Yeah, exactly. You can't be a ham unless you're a lifelong learner. And so, you know, whether it is the engaging educational outcomes we're pulling together, the lesson plans and educational activities, the multiple space stations, starting with the International Space Station and the commercial vehicles that are out there, other commercial activities that might be coming up. We've been talking to a lot of different organizations at this point. And then as we've done with AMSAT, some of the lunar activities, the gateway and orbiters, and we're looking at landers and trying to get on those. And we want to continue. ARIS wants to continue to partner with AMSAT on those, similar to what we were doing when we were developing the ARIS program. And right now we're just, and Randy will talk more about that tomorrow. But right now we're trying to have a strong, not just a prototype, but you know, something that we can move within a couple of years of actually flying in deep space in the lunar environment. We're now a facility on space station. What does that mean? That anybody can come in and ask to utilize some of our equipment. We have an organization that's we've been working with for the past year and a half on that, and you'll hear some news about that pretty soon. And then we've been working pretty strongly with Axiom on their commercial activities on space station. And then we have our educational activities, Stereo Sparky, which is the ARDC grant that we have, ARIS-STAR, which is Space Telerobotics Using Image Radio, which is a ARL Foundation grant we have, and then Student Mission Control that we got with ISS National Lab and the National Science Foundation. The National Science Foundation, we were actually part of that. So, I mean, we've gone from where we were, Mark. It's
awesome.
Yeah. So, you know, over the past year, the fiscal year is where we're showing this because we're at the beginning of November, or October, middle of October. We did 90 contacts in 107 schools. We actually supported one Axiom flight, Axiom 3, with five contacts on that mission. Now, I wanted to talk a little bit about some of the breadth and depth we're doing with schools. And, you know, it takes a village. It's not just ARIS that does this. You know, AMSAT, ARL, and others are engaged in these things. around the world, I'll say. But the first one I want to talk about is the Harbor Creek contact. Many of you may have seen the Today Show on this. I'll show the little clip. And then I'm going to go, that's with high school students. Then I'm going to go to middle school and show you what middle school students have. So let's see if this works.
In a town near Erie, Pennsylvania. NA1SS, this is KC3SGV. A group of students are trying to contact someone who's not particularly easy to reach. Yes, this is KC3SGV. All those numbers and letters are ham radio call signs. NA1SS. 1SS is the International Space Station. A group called ARIS, Amateur Radio on the International Space Station, has organized radio calls between astronauts and some million students worldwide.
What do you do for fun on the space station? Over.
Most of the time, adults do the setup, but at Harbor Creek High School, it's all about the students. Which license do you have?
I have the technical general and amateur extra licenses.
This is the one you use to contact the space station? Did you guys put all of this stuff together?
We've set everything up, from the antennas to the radios, the power supplies, antenna controllers.
NA1SS. Giles calls again.
KC3SGV.
Again.
NA1SS, this is KC3SGV.
Finally.
Hey, Commander Mogensen, we have you at 5-7, a pretty good signal. So, are you ready for some questions?
I'm ready for questions. Go ahead.
Awesome. So, you know, anytime you do a contact and of that magnitude, you saw the look on the students' faces. So let me just say that back, oh yeah, thank you. Back in 2017, we started a education committee. Now that committee has about 30 people in it. The individual that's in our education committee, it was the leader, educator on this contact. And so, and we've got some others too that have really brought amateur radio significantly in and education so that it's a very comprehensive capability. The other one I want to talk about is this, and this just happened a week and a half ago. This Teach Northwest youth that was 8 years old wanted to do a ham radio contact on space station. So his dad didn't know anything. You'll hear the story. So I'll let the story come up. It's this young man here, 13-year-old now, right here. And I'll play it for you.
In a town near
.4 maximum at 148.
Outside the Evergreen Aviation and Space Museum.
We're very excited.
Let me do this. See if I can do this right.
In a town near Erie, Pennsylvania.
NA1SS, this is KC3.
I'll come back to it later. I want to show you this movie, but bottom line, always a glitch when it comes to videos, right?
PowerPoint, right?
Yeah, I know. 13 years old. He built his own antennas, set them up, and had a successful contact. Not only that, but he also developed a azimuth elevation model that out of Legos that he's shown to demonstrate this, and he is in Washington, D.C. right now in a small group of like internationally a STEM like a science fair, and he's attending this weekend. So it's really amazing what he's accomplished. And so this shows the breadth and depth of what we all, AMSAT and ARIS, have been doing together. So thank you. I mentioned also about Axiom. We've had 3 flights with them so far. We've got a 4th one coming up in probably April of next year with astronauts from Hungary, Hungary, India, and Poland will be supporting for about a 10-day mission. The second mission had John Schaffner in it. John is a US-based ham, and he was at one of our schools just recently with another one of our education committee members, providing that color commentary, if you will, what it's like being on space station from a private astronaut perspective. So it's been very good. The whole aspect of us getting involved in Axiom, as well as some other things that are happening right now that I can't talk about because of NDAs, is that we're learning a lot about how to deal with private astronaut activity, both from an industry perspective as well as a private astronaut perspective. And, you know, I'll say the first mission was very difficult for us, but now they're getting better and better every time. And we're learning and they're learning, you know, how to do this better. So the other thing about education, we have moved to a quarterly proposal window now instead of twice a year. And so this is providing us, providing the teachers additional opportunities to submit. And then I mentioned the whole aspect of our education team. We also have these educational ambassadors that are working very closely with improving our relationship between the technical mentors and the ambassadors. Technical mentors set up they help the school set up the stations, and the ambassadors are following the school's educational program. So that's working out really well. And then we've updated our websites on the ARIS.org and our ARISUSA.org to include the Sparky radio kit information as well as lesson plans from USUS. We're continually trying to beef things up. And actually, we've got an initiative right now where we're going to totally revamp all of our websites in the next year. So to make it easier for educators to be involved and things like that. I mentioned Sparky, which was talking about the acronyms, stands for Space Pioneers Amateur Radio Kit Initiative. Okay, and it's a radio kit. The pinnacle of that is the Raspberry Pi that Alan Johnston helped us develop, and we thank Alan's support. He continues to help us on this program. It's really been working out well with us. We just did a mini workshop with the Tuskegee Airmen Youth Program just in August. Actually, tomorrow, I'm not going to be able to be here tomorrow because I'm going to another workshop tomorrow. And one of the things is to show them slow scan television through our radio pilot we have Sparky kit. The other thing we've got going on is this space telerobotics using amateur radio. And what we've done, and if you look carefully on the top right picture, you can see CubeSat Sim board in there. We had some interns, and Alan was involved with the interns a few years ago to actually develop the capability to make these robots work in a number of different ways through amateur radio, Discord, and a few other ways. And what we've done now is we put a little box on top of it to actually take slow scan images. What we're trying to do is emulate how robots work in space, like on Mars and things like that. By having the slow scan television, they can see obstacles slowly and try to figure out how to do it, just like the folks at JPL do for Curiosity and the other rovers, Endurance. So now I want to talk a little bit about the 40-year I give a 40-year retrospective on AMSAT and ARIS and SARX actually together. Just reminding everybody that 1983 is when this all started on the space shuttle. And we've been following the space agencies as they move from shuttle to Mir to International Space Station. And you know, the logo, I didn't even talk about the logo here, is a 40th. It's got all of the organizations that were involved internationally. So SAREX and ARIS, you're very familiar with. SafeX is the German capability on the shuttle, and then MIREX was a combination of ARIS SAREX and others like in Germany and Russia, space station Mir. So this all really started with Perry Klein, you know, on Skylab. Owen Gary wanted to fly amateur radio, and this is the letters that Perry sent for a capability called Skylark, or Skylab Amateur Radio Communication, in 1972. Unfortunately, it came in too late from a NASA perspective, and it was not still, you know, approved, as you are well aware. But you know, as you do anything, you learn lessons along with that. And there were some lessons learned from that both. This was just AMSAT that did it. That, you know, getting ARL and AMSAT together to work on it was one of the lessons. So you know, ARL and AMSAT together went in 1982 with the two Clarks, Tom Clark and Vic Clark at the time, president of ARL, and submitted a proposal for Owen Gary to fly in Space Lab 1. Now, this is November of 82. NASA approved it in April of 83. Now, this got launched in November. So talk about a quick turnaround. And so that just changed everything, basically. So Owen Gary on STS-9 flew through amateur radio. It was a tremendous success, as everybody knows. And in the past 4 years, you know, as a result of what AMSAT and SAREX and ARIS now have done, we've got a bunch of firsts out there that people are doing. You know, NASA does downlinks. Where did they get that idea from? Us, because we did it first. And then, you know, the onboard experiments for students. And then ARISAT and SUITSAT actually showed that you could deploy things off space stations. So now what's going on? They're deploying CubeSats off of space stations. So all of that was AMSAT and ARIS and SAREX and ARL, you know, involved in all of that stuff. So
on orbit.
I just want to basically say these are all the missions we did on SAREX, 25 missions, and we had equipment for all of that in different configurations to make that happen. And this is one of the hardware systems. I show this because it shows AMSAT and ARL prominently with one of our good friends, who's since passed, Ron Priest, W84SIR. And the packet system that was developed was a lot of work by Tom Clark and Bob Berdinga and a few others to actually make that robot system.
They're still working on getting.
Yeah, I hear you. So so basically on space station now we've had three radio stations in there, starting with the FGB, the service module in Columbus. So service module in Columbus, we still have equipment on board. And you can see the packet module in the FGB in Columbus has AMSAT North America right prominently on it here. And this is the equipment. It was all handheld equipment at the time. And actually, we flew that till the IORS came on board in 2020. So we used that for 20 years. This is the new interoperable radio system that was put on board Space Station in 2020. If you'll look carefully, you know, we have a dedication on there to Bill Timing, because Bill was the leader before I came on board. And if you look at the top of the power supply, you can see the AMSAT logo right on there too. So, and then there's SUITSAT. You know, we all flew that together in a spacewalk, and the students got to do artwork and things like that, fly it. So, and basically, you got the third bullet in outreach just blows me away. This is 2006. We had 9 million hits to the SuitSat website, you know, amazing. And like I said at the end here, is that it opened up new opportunities for small sat deployments on space station. So, and then of course, there was a huge effort, especially when AMSAT didn't have a flight at the time, to fly Aerosat, and Barry was a big component of making this happen. Or KDAR, however you wanted to call it. And that was very successful, a great educational opportunity for youth as well as lifelong learners, wherever they are. And then, you know, the last thing I wanted to bring up was we are continually trying to work on deep space and getting ourselves in there. It's a challenge. I mean, I'll tell you, I was trying to get a GPS receiver on board. You think you'd want that, and NASA's been struggling. Some parts of NASA have been struggling to make that happen on Gateway. So we're continually pushing Gateway, and we've got some good contacts that have been working with us. They came to our 40th anniversary, by the way, and gave a presentation. So they're genuinely interested. It's just when the right time is. So in February, we had a celebration conference on the 40th anniversary. I wanted to say a couple words about that, or some pictures, I should say. We had a bunch of panel sessions on all kinds of different aspects of SAREX, of ARIS, and all of the accomplishments over the years, lessons learned, and Barry was there as the AMSAT rep. Thank you, Barry, for being there. He gave the welcome from sponsor welcome from AMSAT, and then also sat in on a couple of panels and appreciated his thoughts on some of that. And then we had a number of educational panels. Actually, the head of NASA education from NASA headquarters came to our event. That just shows you all how much, you know, we're making an impact on education. That the head of education from NASA headquarters spent a day with us and actually held a specific panel as part of this. And one of the many panels we got in education. A mini workshop from Sparky Kit with our team, because we had the ARIS international team there also. So we did that, and that was very, very good, because some of the internationals had never really seen the kit and learned how to use it, and they all left with the kit. So. And we had 6 astronauts. One virtual, because at the last minute he had a family issue. He had to stay home. That was Tony England, who flew on the second flight, did SSTV. We had NASA tours, which you can expect. Lots of friends, lots of younger friends too, which is important. We're trying to build up, you know, both more youth in our programs, as well as, you know, multiple, you know, men and women in it. And we had several launches during the short time we were there. It's just the way it is in Florida now. We had a gala dinner under a Saturn V rocket over at the Kennedy Space Center. And what I can say is that we gave one award out for the 40th anniversary, and that was to Lou. Lou has been involved since the beginning, and all of the hardware systems, Lou has his marks on, so thank you, Lou. We also had extraterrestrial visitors. And like I said, youth are important. They're our new hope. That must have been a Star Trek fan, not a Star Wars fan. Okay, so in the 40 years, you know, together, AMSAT, SARTs, ARIS have pioneered human spaceflight image radio, providing the hardware systems, the operations on shuttle, Mir, and space station. We've been working beyond LEO ops very diligently, and hopefully sooner than later we'll have an opportunity to fly a lunar mission. Brady and I are going to try to work that pretty hard next year. We're going to go to some places. Our education program, the STEAM education program, is both hands, lifelong learners, and youth is really grown and continues to grow. And so what I can say is that when we collaborate, we can do amazing things. And I want to continue to build on the collaboration that we already have with AMSAT and do even more amazing things together. So with that, this is our social media. Thank you.
Thank you very much, Frank. Next up, we got Mark Hammond, number 8 Mike Hotel, and he's going to talk about recent commissioning of MainSat 1, now known as MO122.
I'm done. Good to go. Good afternoon, everybody. Thank you for your attention, and I'm pleased to share what we know about MESAT 1, also known as MO122. And I'm very pleased to continue my service to AMSAT in a variety of capacities, but as a command station and director, it takes special pride in that. So thank you for your continued support of those. First, a description of MESAT 1. It is Maine's first small satellite, that's the MESAT. University of Maine, Orono. It's a 3U CubeSat. It carries 3 imaging experimental payloads that were designed by students from Falmouth High School, Fayberg Academy, and even a middle school, Saco Middle School. So tremendous educational mission.
Saco.
Oh, Saco. What did I say?
Saco.
Oh, that's the watch.
Main
Yeah, okay. MESAT 1 also carries AMSAT's very own linear transponder module, LTM1, for command and control for telemetry, and it's a VU linear transponder. NASA's CubeSat launch initiative, of which we have been the beneficiary, was used successfully to manifest and launch it. And also this program was supported by the Maine Space Grant Consortium. Quick word about the University of Maine Orono. It's referred to as the WiseNet lab, and a primary investigator, Dr. Ali Adebi, serves a variety of capacities for the university, including he's currently the Associate Vice President for Research. He is a Professor of Electrical and Computer Engineering, Director of Experiential Programs and Innovation, as well as involvement in their Center for Undergraduate Research, as well as other activities there. Noteworthy is he is an extra class amateur, Kilo Bravo 1 Victor Juliet Victor, and he's an active VE, not a VEC. Forgive me for that. I need to get rid of the C, but he's involved in giving monthly examinations. So this is not a guy who's into the theory part. He's hands-on and helping make things happen. This satellite was built by University of Maine student team, primarily Joseph Patton, who is a PhD candidate now employed by NASA and continues to work on the completion of his degree. Travis Russell and Steele Muchmore Allen, all graduate students in Dr. Debbie's lab. This is the main publication of which I want to call your attention to make you aware of one of the main references, in which Joseph is the main author on this, but this is the lab and their product. And it's in the IEEE Journal of Radio Frequency Identification, and it's volume 7, 23 is the year. It is a good overview of the development and their approach to it. It includes some of the specs. Some of the parts of the mission weren't even ready, because you can tell from the figures they're computer animated, if you will, their models and things too. So
But this is a good basis for understanding their satellite. I share with you part of the abstract that the purpose of it is to use low cost and low power cameras. And the student missions are hopefully are to analyze water turbidity, right? Cloudiness or, apparent that, urban heat islands and harmful algal blooms from low Earth orbit. So that's their goal, that's their mission. Do note that it is a multispectral remote system using low-cost consumer-grade cameras, and I'll share what we know about it, or what I know about it, and what we have some images of. We don't have full details on this. But another noteworthy thing is the use of a Raspberry Pi computer in the system. And also they developed their own low-cost deployable satellite antenna system to try to, do this whole mission on a budget. So key points thus far, this is University of Maine satellite. This is not AMSAT satellite, but we're a very important partner in it. And I say it includes our linear transponder, and I'll get into some more of the details of what it is. But that's I say that to remind you, to remind us, those of us that are working with them too, that we're a hosted guest, but a key player in this as well. So this is one of the photographs of it. You see it's a 3 UCubeSat. You can see on the one end, the 4 cameras that are covered in the protective film. Some more images. So I have a variety of images for you to just kind of take in what is the satellite. It's pretty well covered by solar panels on the X plus, X minus, Y plus, Y minus. The Z's aren't, and I'll show you what is on the Z's. You saw the one, it was the camera. So this is the instance of the publication included the rendering of the camera assembly. And after launch, Dr. Adebi provided to us some integration photographs and things too. So I've got some other photographs of the actual lenses, but this idea, these are off-the-shelf Raspberry compatible cameras that the students had assembled. Here's an actual photograph of that assembly before integration into the satellite. This is clean room, as you can see. So this is part of the integration of the preparation for the launch. The element that's of interest to us is the 2-meter quarter wave whip. For in this case, that is the let's see, 2 meters up, 70 down. So that's the receiving antenna. And I've got a little closer up here that begins to show you some of the particulars of the deployment system. They did kind of an ingenious, albeit kind of eggs in one basket approach, which is they have a single monofilament line that is melted through the traditional, warm up the resistor, melt the monofilament, which then releases both antennas. And it, gives pretty good evidence that it feeds through the body of the spacecraft in terms of how they did it. So they had a single burn opportunity to release both antennas, which is a little different than from our standard approach and from some other approaches. But again, they were very pleased because they built it for next to nothing compared to some of the commercial systems. So it fit their guidance. This is Ali Adebi, and this is his principal lead on it, who is continuing to work on his doctoral degree as they are working on the actual integration. So this satellite was constructed and finished, and I'll get to that, but in about 22, and it literally sat on the shelf, according to Ali, for 2 years as they're waiting for the launch. So this is their clean room preparations and integrations. More images of the 4 cameras with the protective film. This, I found out for sure, and it's been a conversation point a couple times already in our symposium. They have on this satellite a system that's referred to or called or branded the iStar system, and it's a GPS system. So it has ability to gather, glean, and report and set its position in orbit. Our payload, if you will, our LTM, is involved in making use of that information, and aren't we? It burns, I think, right, to help set the clock.
At some
Yeah,
point,
yeah, that's right.
yeah,
We get
you know,
time from it.
yeah, we get a time from it, and it's worked out pretty well. It has to be a part of the activation of the camera system, and I'll talk about that in a minute. But this is really some of the first views of this that we got to see of this iStar system. So it works. You know, we are using it in orbit. Here's the unprotected camera lenses. Here is the launcher going into the pod or the dispenser. Camera's out, and that pretty well sets the stage for talking about the next part of the satellite composition or construction, which is of particular interest to us, which is our linear transponder module. It is a VU inverting linear transponder, 30 kilohertz. There are the relevant uplinks and downlink information. This is a really great example of the engineering accomplishments of our colleagues in the engineering realm of AMSAT, in that this thing puts out about a watt of power across that 30 kilohertz. And it's strong, it's clear, and this is really good evidence of their continued improvement on the linear transponder module as a payload or as a transceiver. And this one, as Drew put it something this morning or yesterday, it's like, it's ready. It's matured, and we've got one. So the telemetry beacon has a downlink at 435.800 megahertz, and nominally on your sort of state-of-the-art radio, the ICOM 9700, you know, put it on upper sideband and do a little bit of frequency offset for that sideband, and that pretty well sets up the audio frequency for the input into the telemetry decoding program, Fox Dilemma, which some of you or many of you are familiar, and I'll talk a little bit more about. Telemetry format, it's a 1200 baud BPSK. It is supported by Fox Telem. A little bit of promo that there is I hope, and who knows, sometimes there's a more recent one that's dangerous to put up, but Chris is saying this is current 1.12 Z7, which is one that will incorporates a few tweaks after MESAT launch to analyze the telemetry. So what's neat about it is that not only does it transmit live telemetry, it has what those of us that don't have to write the software for call a simple whole orbit data system. And excuse me, I'm calling it store and download more so than store and forward, which tends to be kind of our old PACSAT PBBS message. But this satellite stores the telemetry for some period of time, which is adjustable, and it then cycles through. And so the more stations we have collecting it, the more data that we get. And now that we're running pretty much 24/7, and I'll talk a little bit more about that in a second, we have a lot of data coming down out of the satellite, both live and historic. That gives us a really nice picture of what in the world's happening with the satellite. So the satellite was completed, as I said, in 22. It earned a launch on Alana 43, which that launch included 8 CubeSats, and it was on the Firefly mission. And I think that's the first, is that the first Firefly mission?
Successful.
Yeah.
The reason
Right.
it sat was the first one didn't go so well.
Yeah, first one was in geostationary orbit sooner than what we thought, meaning it went up, it came down, and it stuck in the ground. So it was fun to watch. They got pretty short notice of the window of time from when it was, you know, not doing anything for 2 years until, hey, get it ready and we're going to go. So they got to go. So it launched on July 4th. Was it close to July 5th UTC, I think, or something, but it was real late, and it was a fun launch, and then we start to listen, right? So talk a little bit about early commissioning. First evidence, look, and I may have some of these details wrong. The good news, those of you in the room who know I'm saying something wrong, call me on it during the talk. But the first evidence of the telemetry beacon was from the Bochum Observatory, and that happened within 24 hours of launch. That's a big window.
Dwingelo, I think.
Was it Dwingelo? The big dish.
The Dutch one.
The Dutch one, Dwingelo. That's, I was I knew that. Oh, thanks. Yeah, she's hearing me choke up here. Thanks. I'm so nervous. No.
Really?
You can tell, yeah. I've never done this before. Yeah. So the signals were weak, and that's why the Dwinglow dish evidence, they saw it, and we were having trouble. So we entertained the idea that perhaps there were some antenna deployment issues. In fact, the sensor telemetry data is got a flipped logic to it for a number of us about what zeros meant and what ones meant when you looked at the antenna deployment. And the only person in the universe that really knew how to decode that was Burns Fisher, who was out of country during the launch of all times. Burns, you got to schedule things better.
For the launch to happen.
Yeah, well, you can't change a launch very easily, but flights, no. So we found out. So I'll continue the story a little bit. The reality is the antennas in the satellite geometry puts the antennas like to the side. It isn't your traditional like from the ends or I'll show you an image of it. It's actually a graphic, but the position of the antennas matters because we see some fading in some things too. But early on, we weren't sure if the antennas had been deployed. Had been pretty quiet. And if you consider the length of a 70-centimeter quarter wave, right, relative to a 3U CubeSat, I mean, there is a lot of geometry where that thing could be hidden, right? If it's not on the end in particular, and if, depending on its orientation. So this is just their rendered version, from their publication, that you could see that you could pretty easily obstruct that antenna depending on the position and geometry of the satellite. Now, many of the satellite missions that we work on or the satellites that we use will have, a magnet in it, right, or an Earth magnet in it that will provide it with some orientation and things that keeps it pretty consistent. That is not the case with this one. Okay, it has some magnet torquers in for it, but I just wanted to show you. So keep this image in your mind as we're beginning to, try to listen and command this satellite. The first packet was received by a SatNog station. It's KU4YJs in about 0200 UTC on July 6th. Chris, our very own BE2 TCP is a call I have to get used to writing down, or K0KL, G0. The first live frame copy and the first commands were sent almost after that first packet was received by the SatNog station by our very own Drew, KO4MA, about the same time. Additional frames had been processed from the SatNog recordings. It was receptive to commanding, and so Drew was able to command it and increase the telemetry gain so that we could have a better chance of getting more packets in hearing it. And so what's neat about it is this is adjustable in 1 dB increments. And you can see the current level of the telemetry beacon in the FoxTelem program. And I've got it circled here. So if you use FoxTelem or look at the web page, this value right here tells you what is the current setting. And as of today, unless we had a reset while we were in session, we've got it gain it set at 17. Default from reset is in the safe levels is a -19, and so -17 is 2 dB more gain, so we can adjust that. How high did we go so far? 14, 13?
Yeah.
I forgot. And it's pretty loud when you crank it up like that, but it's a power management thing. So telemetry can be routinely copied. People say, what does it take to hear it? Routinely with one of the classic and current M2 Leopac class stations with a mass-mounted preamp, good low noise and few or obstructions. Promotion, yes, you can order that antenna system through our website. It's very popular and it's been used a lot, particularly on Green Cube and other matters too. It's just a phenomenal package for the size of it. I mean, it's short and got a lot of gain and just works great. And I can highly recommend it. What would be a minimal system? So far, I think the minimal system demonstrated is a Fox in a box. Burns has a Fox in a box on I guess it's an M² J pole. No, Arrow J pole. Arrow J pole in Hawaii. And when we put the beacon up a little bit from where it is now, somewhere around a telemetry setting of 16 or 15, he gets some frames out of it there. So just to give you some idea, what does it take to copy? This is just a great big overview showing you, if you were to compare that to like our first Fox satellites, AO85 and that Fox 1 line, tremendous amount of telemetry data and things coming out of this satellite. So it's got a lot of sensors and a lot of data for us to do. But what I want to show you is it's also in Fox Telem. So this is a display of Fox telemetry. Health tab is selected here, which is the information that we collect live. And then this is the whole orbit data or the WAD, which is the information that is the historic information too that we can collect. So you can click on these, graph them, and plot them out. I did a little bit of that, and I'll talk about. So commissioning, it includes 4 off-the-shelf RPI cameras. As you saw a picture, the images, we can command it to take a picture now, or we can schedule it for some time in the future. And what's neat about the scheduled timeframes is there's a magnetorquer system on board that will help stabilize the satellite before the image is taken. We can also choose where it is rather than being limited by the footprint of a command station. Between Drew in Florida and me in North Carolina, we got a pretty good East Coast, but if we want to do any place around the world, the time's set. The images must be downloaded individually in blocks. And the data is stored in the images as multiple channels due to the multiple lenses and the filters and things. And you get about 2 blocks per pass is what we're finding now. And Fox Telem magically assembles those blocks into images. So briefly, this is to show you that the different lenses cover different wavelengths of light, which is their approach to looking at the different biological things that the high school and middle school had proposed for looking at turbidity or algal blooms. And so some details about the cameras and the wavelengths of light and the filter setups that they have for each of those cameras. I'm sorry. It's worth noting that 3 operational modes exist for this satellite, what's called safe mode, what's called health mode, and what's called science mode. Safe mode is the most power savings, and that's where the telemetry frame is sent about every 2 minutes, a 10 to 11 second frame is sent, and then it's silent. True. Right. I'm sorry, what did I say?
You said 8 frames.
Oh, 2 frames are sent every 2 minutes, yeah. And then they have stuff bundled in them, so, you know, between frames and payload. But it's infrequent, it's hard to tune, and it's hard to debug early on. So safe mode is great, but it's really hard to get much data. But least power consumption, and that can be commanded on or can be triggered by spacecraft parameters. To date, we haven't had it auto trigger into safe mode. It has not automatically gone into safe mode. So it's got pretty good power budget, and we're also being very careful about how we treat it. Health mode is kind of the standard normal mode where the transmitter beacon is on all the time and sending frames continuously. And then the linear transponder can be either enabled or disabled during that time. In science mode is when the picture images are sent. But at the same time, I think it's correct to say there's no telemetry frames embedded in that. It's all about the image. And so
it's a bug. You're supposed to be.
Future editions of this will include telemetry frames mixed in. I'm going to try and get us back on schedule. I got a couple more minutes. Okay. If you look at the telemetry from Fox Telem, this is from launch, July 4th, until about 2 or 3 days ago when I threw this presentation together. What's fun is you can see areas where different things are happening, and I've highlighted where we were doing the camera testing, because there's lots of variability. And it's like, what are these fields? It's showing you whether the onboard computer's active, whether the CAN controller's active, and whether the iStar GPS system has been activated or not too. So you can see lots of activity. These in particular are the ones that are showing you as being enabled or disabled. So my pitch is y'all can go look at all of this, you know, this data and whatnot too, and see these trends and see what we've been up to and what we've been testing. We had to characterize the camera system in relation to the power budget. We found that when all the modules are enabled, the power budget is challenged. It's right on the edge, and it can take some effort to, you know, we put considerable effort into determining the sequencing of enabling and disabling for successful images and downloading those images. But my pitch here is you can also see in the telemetry at any given time if something has been enabled or is running disabled, and we learned how to toggle all those off and on in particular sequences. So what we discovered was that the camera system We needed to work on it with the satellite in safe mode as a power savings means to ensure that when we did take an image, that it was successful to take an image and downlink it to us. I like to say the raspberry needed some juice. This is a slide I think came from Chris that shows with Raspberry Pi active, and that's the onboard computer. It was enabled, and down here it's disabled. And what you can see is, in particular, we're not going as far deep into the batteries with the RPi turned off. In other words, the RPi takes some juice, and that was just a sample of many of the things that we were working on trying to do this, figure out the satellite, characterize it. I said it mentioned it had a magnetorquer. I can't find a real photograph of the magnetorquer, but this is their cartoon of it, if you will. This is an off-the-shelf one. But cool news is the magnetorquers work. So you can see, looking at the X and Y and the Z magnetorquer values, that ordinarily is pretty flat. And so when we set up a commanded image to be taken, we can look back in the telemetry and see these perturbations in the data that says, yeah, magnetorquers are working. So it's pretty good. Likewise, there are some indications of motion. And if you look at those confirm as well that it's slowed down. So here's some images. As you can clearly see, it's kind of a splotchy gray thing. We worked pretty hard to get these.
days and days.
Couple months, yeah. But it's because it's in blocks and it's subsequent, consecutive downloads and all of this and Chris's magic at putting them together in Foxtel. But these represent different images or different parts, different channels of different images. And this is one that's mostly complete. And the reality is many of these images looked like this. This was a test image they had on board, and we could successfully download that, and that was just, a geographic thing. But this is one of the better images, and what we lack is sufficient information to really decode that or evaluate that. So that's where our academic partner comes in, the university, and we need the university to look at this data. So this stuff, I guess at this point, this is almost 2 months old, but we've been working on it pretty recently. So summary of camera testing, the magnetorquers appear to stabilize the spacecraft. The camera system appears to work. Test images, we took at various locations around the globe thanks to the scheduled image taking. We're awaiting interpretation of images by the next batch of UMaine students. When you have a 2-year on the shelf, when you have grad students that are in 2- and 3-year programs, even doctoral programs, they graduate. So the good news, I got an email from him, I guess it was yesterday, Dr. Benigan. He has a student lined up that he thinks is going to begin to take on some of the, at least Foxtel data and look at this too. To wrap up, first QSO on MESAT 1. It was the second transponder test because we turned it on, but it was the first QSO. It was about 0100 UTC on July 23. Kilo Quebec for Slim Jim Man, SJM, Karsten Glasbrenner, and me. We had a nice conversation on, and that's a young man sitting up here, 12-year-old man. So there aren't many 12-year-olds who get a first QSO on a satellite, right? So we had a lot of fun with that. So we demonstrated a few watts to a typical array, is sufficient for a QSO, but satellite position and attitude is important, again, because of the obstruction of it. Here's a nice SDR picture. Here's the beacon. Here's one of the sides of the QSO and things, and that's thanks to Charlie Oscar 2 Echo Sierra Papa, who took that image and was listening to it as we were testing it. So he sent it to us and shared that. I should put it on Twitter. Other lessons learned, the satellite appears healthy. Transponder is working great. It's working great. Adjustable gain, great idea, works really well. Measurement of battery capacity is useful. What's battery capacity? We don't know. It's a value that shows up on telemetry that's beyond the voltage. So if orange is the voltage, you see we had a dip. We had an event or we had an occurrence. We don't quite know what it is because it wasn't really during an experiment. And then the blue zigzagging along there is the capacity. But what we're finding out, so this is just the capacity, we're finding out that the capacity is a really good lead indicator for what's going on with the batteries, even more so than the voltage. So we're going to find out. I'm going to try and find out, exactly what it was in that satellite, because I think it's something we can put. Other lessons learned, there appears to be noise when the satellite's in sunlight. Yellow means the bird is in illumination. A yellow is eclipse, and what you can see is it's very quiet. So there's a little bit of noise while we're in the sunlight. There's interesting too, we saw a really neat correlation between battery 3 heater and the transmit level. So if you, when we have high RF, so we think, you think eliminating RFI in the shack is hard, how about a satellite in orbit? So this shows really excellent correlation of when we have things enabled running some power and when that battery heater is going on. So RFI, our model is RFI is triggering the battery heater on for battery 3 and occasionally battery 6, but just stuff we've learned. So current status, it's healthy. It's supporting nearly 24/7 health mode operations with transponder on. We've only had to give it a break one time. It may be from time to time we need to do that, but we're happy to use the battery capacity as an indicator. And so analysis of existing images and camera testing is anticipated soon. And like I say, Ali gave me confirmation of that. Acknowledgements to this commissioning team, KO4MA, TCP, Burns Fisher, Paul Stotzer. We met a lot of hours on Zoom and did a lot of conversations. We're figuring this thing out, and I appreciate all of them. The entire AMSAT LTM team, especially Eric and colleagues. Cable University radio station, that's a university where I have worked for over 30 years, and I have the privilege of remote operation of that station. If you donate the station, they usually will let you remotely operate it too, by the way. So that's where we use a lot of telemetry commanding to the station, but then resources, these are the links, and if you want those links, I'll be happy to share. But that's it. Thanks.
Thank you.
Question in the back.
Sunlight, what was that showing up?
We see it in the telemetry. We're seeing it.
Telemetry of what?
Oh yeah. Remind me. Was that?
Just whatever the cues.
Yeah, we saw it in command receiver, but we saw yeah. This is plotting battery current. And in other words, we don't think really that the battery current's going up and down quite like that. That's sort of an atypical battery current in the sun. So that's what we're saying is the noise. Eclipse is showing you nice and smooth, but now you put it in the sun. And Drew said the Floridian, right, said, well, that's solar panel noise. So that's our best guess is that there's solar panel noise getting into some things, and we see it just in the capacity. Yeah, Red.
What about all this solar activity that we've had lately? Think that's doing anything to your telemetry?
I don't know. I was trying to get telemetry about 2 nights ago, and I thought something's wrong with the university station or something's wrong with the transmitter. And I was sending it commands. I thought it went through a reset. It wasn't. Others were getting it. Anyhow, it was like incredible pumping AGC. So I might have seen it, I'll say, on the 70 centimeter downlink. But other than that, I don't know. Yeah. Yep.
Yeah.
Well, no, thank you for bringing that up. Yeah. Yeah.
Can I use
Please.
So during some of the initial conferences we were having while we were trying to commission this, it just seemed to me, anybody remember the Greatest American Hero TV show from the 80s? We got the super suit, but we didn't get the manual with it. So it was like 3 people saw that show now. I'm embarrassed.
Yeah.
Yeah. So we were kind of bumping around blind with it.
Yeah.
And this is all because Maine, all the students
are gone. Yeah.
And they didn't even have a station at this point. So that's why we were stepping up and doing all this work commissioning near satellite for them when it was really just our transponder in there. So thank you, Mark. Yep. And next we've got Michael Lipp for the Hotel Bravo 9 Whiskey Delta Fox from AMSAT Switzerland, going to give us an update. Take your time. We'll run a little long if we need to. I know we're behind schedule.
Thank you, Drew.
And believe me, Mark, I'm much nervouser than you.
Oh, okay.
And I can't speak so fast English than you. I give it a try.
But it's more clear than mine.
Okay. Last year I had the honor to introduce AMSAT HD at this symposium, and this year I give you a little update to this information. In 2021, we established AMSAT HD, and we expected a potential of 25 members on the whole Switzerland area. Now, in September 24, we got our 46 member, and it's great to see how it's growing in Switzerland, and not only because of Q100, also because of the LEO satellite. That's amazing. That's a very good thing, yeah. So our huge public outreach this year was in Basel at the Fantasy Basel, the Swiss Comic Con. There were over 3 days, 88,000 people, 88,000 visitors. Not all was on our booth, but it looks amazing. We had some of the Stormtroopers, but also the fantasy figures. And it was a big surprise for us. They didn't know what is ham radio. And they said to us, hey, I have experience in SDR radio, but what is amateur radio? So that was a big connection between us, and that was really a big surprise and a success for us over the 3 days. We had super connections, and yes, we do it this next year again with a bigger booth, with much more people there. And yes, we had the CubeSat simulator also there, and it was very neat. The people come from the maker scene and was very surprised what this is. It's a CubeSat simulator. So also on the left side, you see on the left, this is Armin Roche, Hotel Bravo 9 Mike Foxtrot Lima. He is right now the command station of the Silink satellite, our very first satellite from Switzerland. And on the right, this is Dr. Renato Carton. He is the leader of the Swiss Space Office, like similar in the NASA. And Dr. Renato Carton was also team member of the Swiss Cube satellite. And we have a good talk together. On the right side, you see some amateur radio operators who is also in the cosmic plane scene. And they were very surprised to find us there at the fantasy in Basel. There is also, again, Armin Roche here in the middle in his shack with a command station from the Swiss Cube. And the Swiss Cube satellite has this year is 15 years of celebration. And in his shack, there are new pupils from CPLD Lausanne, from the University of Lausanne, who are right now building a new satellite. Unfortunately, not an amateur radio satellite, but they are very interested how you command a satellite in space, and we teach them. And that's the role of Armin, and he do it very, very well with his shack. Right as a model in the Swiss Transport Museum Lucerne from the Swiss satellite. We are in the review team of ARIS Sage. Last year, I introduced this new project. ARIS is a German acronym for Akademische Raumfahrtinitiative Schweiz, or in English, Academic Space Flight Initiative Switzerland. And SAGE is the CubeSat project, Swiss Artificial Gravity Experiment. The ARIS have 3 departments of projects. They build sounding rockets with the guided rocket recovery project. In the middle, we have the CubeSat SAGE project, and they have also an unmanned on-water vehicle. It's also very exciting what they do. And I think once they build combination all these projects together. In this ARIS team are over 100 members. and in several projects. And it's very exciting to see how many young people are interested in space, space stuff. And we cooperate with the RSH team. That's one of the hugest groups from the RS team. And I know some of them are right now on the live stream, and I say hello to Switzerland again. And you can ask them via the YouTube commentary some questions about this project. Here on the showcase event this year, on the left side, Oliver Stabler from the SAGE team, and right, Chantal Lovi, also from the SAGE team. In the middle is Professor Martin Klauer, HB9 Alpha Romeo Kilo from AMSAT HB doing the review. You can see the SAGE satellite is right now in 3U CubeSat. And you can spot here the S-band antenna, which is 40 centimeter antenna, and UHF dipoles. The main goal of this RSH program is cell aging, research into cell aging in zero gravity for future space mission, then generating artificial gravity in a CubeSat. And our main interest, where we are also in the review team, is the ham radio payload communication part, and they do also research for MCU. Before I go to the RF boards, it's very interesting what they do in the science payload. Here on the left side, you can see the cancer cells. These cancer cells must have an environment about 37 degrees Celsius, and these microtubes around them, these microtubes supply cells with nutrient solution. And then we have here on the right side microscope taking pictures from the cells and transmit that via the amateur radio telemetry to the ground, so you can receive these pictures, source, and doing yourself research in this part of cell growing. So now the RF boards, there are two boards inside, a standard SAT-NOTS board for the main communication for supported telemetry and picture data. And on the right side, you can see the development board for US linear transponder. If you have already your equipment from also 40 for the doubling of 30 centimeter, you can use it for this satellite in the future. This board that has 1 watt RF power output going in S-band patch antenna and receiving with UHF dipole. And it can be used for backup telemetry. Right now, they're developing in the CubeSat standard form factor, so they can use it then for the satellite. The launch, not earlier than 2026. Last year I told you that's 25, now it's 26. They have also problems in the supply chain, and already with the budget, the material is getting expensive, and so it's over the budget. But I think they found the right solution, and the target orbit is 510 kilometers LEO. We had also a public outreach with the team from RSH in the Swiss Transport Museum a few weeks ago. It was very funny. There is a sounding rocket that's 15 feet tall, yeah. And they built with the kids such paper rockets, and we let them fly with air pressure. There is a bicycle pump on the left side. We put it on and switch the valve, and they fly very high, about 30 feet, and that was very fun. We built over 1,000 rockets in 3 days. So, and on the right corner, they built the Rosetta paper road. This was also very fun to work with the little kids. By the way, there is another ARIS launch date. Rabia Roque is also a team member from ARIS SAGE, and she's responsible for the avionics. And I was very surprised that Frank and No here. That's really new for me, because Rabea is a team of the SpaceX mission Frame 2 next year. We're very happy about that. She's not from Switzerland, she's already from Germany. Actually, it will be the very first female astronaut from Germany. And that's very exciting for us. So that was already stage. Few of you remember this picture. This is already the new picture. It was taken by Peter Gulsoff a few weeks ago. This is an AHU from Oscar 40. Before I go further with this theme, Peter had plans to be here in Tampa this year, but unfortunately he got an appointment for a surgery that was happened a few days ago. I had contact with Peter a few minutes ago. Doing well. You're watching the live stream. Hey, Peter, all the best for you, for your recovery, and hope meet you sometimes in a better condition here at the Symposium. So why I show you this picture? Back in 2016-17, we had planned to recover Oscar 40. And there was a team, I was part of this team from AMSAT Germany. And yeah, it's very, very difficult to get in this satellite. We have first to learn how things work. Why we do that not then? We stopped this project because SL2 and Q100 needs all resources from AMSAT Germany. So we stopped this project. Now we have fresh energy, there are new team members, and they will figure out how the AHU from Oscar 40 works. And then a second, why we not try to recover Oscar 40? So we got the hardware, we got software, and now we figure out what happens exactly in 2003, 20 years ago. And we hope for an Oscar 7 effect. But I have to say, the chance for recovery is bigger than zero, but not much more. Not much more. But when we have success, yay!
Yeah.
Okay. Then another exciting news from AMSAT HB. Hotel Bravo 9 Radio Golf was the call sign of Hans-Rudi Lauber. His silent case in 6 years. Unfortunately, it was an amazing operator. In 2022, AMSAT HB got his call sign. It's a very own big honor for us. Hans-Rudi Lauber and Alfons Hering, W6 Ecos Alpha, succeeded in establishing the first amateur radio QSO via an amateur radio satellite on March 10, 1965 via Oscar 3. So next year, we have to celebrate 60 years of the very first QSO via satellite. And we will celebrate that from the AMSAT HB with a special HB9 Radio Golf Trophy. More details soon. We're working at that, and will not only for Q100, it will be also for yourself for the whole world. So that's my last slide, and you can see here astronaut Claude Nicollier. Claude Nicollier was our very first astronaut, and the only Swiss man who was in space. He was a 4-time space shuttle astronaut, 2 of them for the Hubble mission, Hubble repair mission. Very exciting. And yeah, he had an advice to our new astronaut. It's Markus Sieber. It's our new astronaut. And the hint from former astronaut Bob Nicolay, hey, no Swiss in space without chocolate. The response from Marco is, yeah, maybe sometime also with Swiss cheese fondue. That's hell crazy. Our motto from AMSAT HB, bring good friends, Swiss chocolate. Adrian do that from Romania with the Romania chocolate. Thank you very much. And the back, I have Swiss chocolate for you. I'll take it and have fun. Thank you very much. It's everything.
Thank you, Michael. Great stuff. We've seen all the pictures there. They're awesome. Next up, we're going to have a Vox Plus update from Mike Moore, Kilo 4, Mike Victor Mike. It's going to take us a second to get a computer rearranged here, so bear with me.
Oh, bright light.
B.
Huh?
B. I hit B to
B.
blank. B to bring it
Oh,
back.
okay.
B.
Every day is a learning day.
I wasn't intentionally blanking the light out with my head.
Makes a nice shadow. Sasquatch.
Spherical yet quite pointy at parts. Just hit the space bar. Okay.
Okay, good afternoon. My name's Mike Moore. I'm Kilo 4 Mike Victor Mike. I'm the system engineer for Fox Plus. And I've been asked to give an update on Fox Plus. So here, my plane just got in at 3, but. Okay, first I just want to tell you what Fox Plus is a little bit for those that don't know. It's for us to try to put some 1U CubeSats on the shelf, ready to go on a moment's notice when we have payload university partners or other customers that want to fly something. We want to have something on the shelf that we can get out to them quickly. So that's the idea. When they conceived this, they decided that the fastest way to do it would be to purchase some commercial off-the-shelf components. So we were purchasing the EPS solar panels, the frame, and the antenna system from ISI Space, which is a Dutch company, which makes things interesting when we're trying to get things in. The last presentation had a lot on the LTM, which is really good, so that's a good segue.
There we go.
Okay, the Fox Plus CubeSat looks like this. It's a 1U structure. I've got the, this is the ISI Space Compact EPS here, their antenna system over there. And this is a fairly accurate block diagram of it. LTM up here, and the operational payload, optional experimental payload. One of the ones we're talking about flying first is PACSAT. We've got Bill here that does PACSAT, so. I didn't know it does this. So showing the ISI Space components a little bit, just for those not familiar. So what we're using is the Type B IC EPS, and that is so we can separate the battery pack from the main PIU, the interface unit for the antenna system, again from ISI Space, is very interesting. I've been messing with that this week. I'll show some slides on that. But the cool thing about it is each antenna has 2 burn resistors. So it has redundant burn resistors where the burn wire goes over top of it. And this is fun to rethread when you deploy the antennas in testing. But anyway. This is just right off their website. I do not have a good picture of the solar panels. I'll be talking about them in a minute. They are being shipped to us this week. Here's some testing going on. This was fairly recently. We were developing this cable. This is well, we're not developing it. We're building it and we're ordering it. It's very expensive. The connectors they use are these Omnetics A28000-009 connectors, and they're nano D-type connectors, 9 pins, and they cost hundreds of dollars each. And so we're messing with that. But anyway, this was the antennas deployed. So you can see the antennas out here. We're using 2 antennas per band. So we have dipole antennas for VHF and UHF. This I put on here because I was so proud that I got it back together. You have to really kind of fiddle with it, but it's a very good design. I'm very impressed with their design. Okay, software status. We really have 3 software apps or entities that we deal with, and they talked about it in the last presentation, but there's really 3 things that we have to address. We have the flight software. Right now we're using the HuskySat software for testing. So that's the embedded software on the LIHU. Then we have AMCOM software, which is for over-the-air testing. And we have Fox to Limb for the ground station. And we have our software guru here, Burns Fisher, and he's the expert on all this. And he's training a couple of software guys for Fox Plus right now. Cliff Jenkins and Will Rosenbeck. Yeah, all these require Fox Plus revisions, and they have not been revised as yet. Okay, so where are we on Fox Plus? We have system engineering documentation, the ICD, in progress. We're trying to get that to PACSAT. The software status is shown on the last slide. Solar panels, as I said, are shipping this week. So we have not really even put the CubeSat together as yet. An interesting thing on that is that, when this was first conceived, this project, I think they felt that a 1U CubeSat is a 1U CubeSat, so no big deal using COTS products and then integrating our LTM into it. That turned out not to be the case. It's ISI space. It is based on the what's it called? The Pumpkin CSKB standard, but we are not. And we use a profile that called within AMSAT, it's called the ME113 profile. And the boards do not quite line up. So our mechanical engineer, Andrew Robinson, is putting this stuff together. We need an adapter to interface the EPS to the FIHU. Then we've got the LTM modules that we just talked about, but we have to have a separate, a new LIHU. This is version 7. for Fox Plus. And this is closely related to the Husky Sat, LIHU. But we've got a bunch of 0 ohm resistors, AKA jumpers, to bring in some signals and keep out others. I don't have details on that right now, but that was a big part of developing the new LIHU. The ICR, we're testing version 2.1 right now. Leandra is working on that. We've got version 2.2 in progress. Version 2.2, we don't even have boards built yet. So we're trying to get the boards put together on that. The RXTX card, again, is in process of being built. So we have none of the engineering model boards built for Fox Plus as yet. So we're not as far along as maybe some people thought we were. I would say we are less than 50% on my Gantt chart on my project plan. And we're showing somewhere around 45% completion. And it's we've got a lot of development to do in the near future. Oops. How do I go back? Just B. How do I go back?
Try an arrow.
No, that was it.
That one?
No, next.
And then it,
Yeah,
there you go.
So here's our high level schedule. And you know, I'm kind of the new kid on the block as far as the engineering goes for AMSAT. So I've been with this for about 3 years. And we completed the CANAS back in 2022. We've got into the ISI space components and everything 2023. And we are running out of 2024. And we're just now getting parts, as I said. And so our next thing is we're having a project status review. We decided to go with a project status review to see where we are and if or how soon we can be ready for a PDR, project design review. We don't feel that we're ready for it yet, and so we want to see how soon we can be ready. Oops, should have did it again. So our next milestones are the project status review, November 6th. When we get back from this symposium, then we've got 1 week to get ready for that. I'm being very optimistic and hoping we can do the PDR within a month from that. So like December 6th. And again, that's been kind of optimistic. And then our CDR, in which we have to have all our EM builds complete, software at least in decent shape to be testing everything. We're hoping to do that in May. And all of this leads us up to, if we go back to that chart, to try to have a launch by the end of 2025. So initially, we wanted to try to get a launch 3rd quarter of 2025. But everything we do, because we're all volunteers, everything keeps kind of moving to the right. Everything gets later and later. So we just recently had a pep talk with the engineers on the team. And we're trying to get people to really come out for it. And it's even golf is really a big effort coming up. So there's a lot of stuff going on with the engineering team. So I want to, I already did this. I wanted to thank the volunteers that are Fox Plus. These are kind of dedicated Fox Plus engineers. There's others, Burns, Joseph. We have all kinds of people that help Fox Plus, but these are kind of the dedicated engineers. So I've got Andrew Robinson, KA3WDW. Cliff Jenkins is going to be doing software. He is doing software. KE8JAE. We've got Will Brozovic, software. Leandra, AF1R. She's a double E, and she does a lot of good things. She's helping us with boards and with testing. Patrick Thomas is system engineer and PACSAT liaison, and he's doing the ICD right now. And that is about it. Any questions?
Do you have any known,
Pardon me?
do you have any known showstoppers?
Known showstoppers. We have, we don't have any showstoppers. We have some hubs we have to get over. We've got the adapter for the mechanical, and we've got software that I feel that we need to get more of a handle on. The software changes, we've got things that are in the software right now that can be taken out, for instance. That, yeah, but
I think it's fair to say about the software that, yes, you're right, things need to be removed.
Yeah.
Because the software is the same software in general, it's used all the way from parts one. So it's not like you're starting from scratch.
right. Yeah, it's more removing all of it than adding. Yes, sir.
Nice to see that antenna deployment system in action. As I've got that to look forward to, how long did it take you to repack those antennas in that tiny little structure?
It takes me to do all 4 of them. It took me a morning. It took me about 4 hours.
How about the second time?
Yeah, that's a little faster second because I learned some tricks.
Yeah.
Yeah, you learn some tricks. One of the worst parts is they call it burn wires, but it's really like burn strings. You know, it's a thread. You know, and you have to catch that on a spring with an eyelet that's about 5 millimeters. And so everything I have to use, opticals. I have to have magnification and everything, and it's tedious, but it's well worth it. It's and you feel like you accomplished something when you get back.
Perhaps you could do a training video.
Yeah,
Well,
YouTube.
It sounds like threading and a sewing needle.
My wife's a sewer and a quilter, and she gave me a little thing for to thread a needle with me.
Oh, yeah, okay.
Needle threader.
Yeah, needle threader.
Yes, sir, Joseph.
Where are those antennas placed on the spacecraft? Equator or at the end?
They're at the end. They're at the minus Z. It's the only. In fact, on the Fox Plus design, excuse me, on the system, we're not putting solar cells on top of the antenna. So you've got 5 sides.
That was my next question.
Yeah, 5-side solar cells. So you've got, if I had the solar cells, if I'd done a better job, I would have showed you the top solar cell versus the sides. But yeah, there's nothing.
What was the reason for that decision of not only using 5 panels?
Just the I don't remember the reasons, to be honest with you, but this is back to the beginning when we were looking at it and looking at the ISI space components. The antenna system has a cover on it, of course, and you can put solar cell on the solar panel, but we just did not. And these are very expensive. We just paid 35,500 euros for 10. That's expensive. Any other questions? Yes, sir.
When the antennas are deployed, do they come out like a tape measure or do they spring out?
But they spring out. It's
So it like emerges like a tape measure?
no, it
swings.
Okay. Yeah, stay out of the way. You know, it's
Okay.
like-
Lose a finger.
That's why I had them on
The stool,
there,
yeah.
my test bench stool.
Yeah.
I put it down there so it had room to spring out, you know, because if you have it up on your test bench, you can knock things off or whatever.
Was that nitinol wire?
Yes, it is.
Thank you.
Yeah.
Thanks.
Very well. And that-
Okay, guys, we ended up 12 minutes ahead of schedule. So we're gonna break for dinner. Dinner's on your own. There's of course the restaurant here to the east. If you follow the road and the sidewalk around, it's not too very far to Bahama Breeze, which is a nice place. And if you go across 60 and down just a hair, there's Whiskey Joe's, which is a seafood place right on the water. So we're going to get back together around 7 o'clock for the attitude adjustment and bar. And then we'll have our AMSAT auction where we'll try to send some junk home that'll probably get you scanned by the TSA 2 or 3 times.
Wait, I'll give a promo.
We're driving a truck. We can take them.
Drew serves as the auctioneer, and you never know what you might get. This shirt, and this shirt I earned, I won at the auction last year. It's Tom Clark's shirt. So you never know what you might be able to buy at an AMSAT auction, right?
Don't wash it. That exact shirt.
Yep. Yes. Yep.
All right, thanks a lot, guys. See you in a couple hours.
I think